Hey everyone, Connor Svensson here, one of the session hosts. We'll just wait for a few more people to come on board and then we'll kick things off, okay?
Sounds good. Thanks, Connor.
Hey guys, how's it going?
Hey, Carl.
What's up?
So I think we'd maybe give it another couple of minutes before we kick things off, just to make sure everyone's here who wants to be here. So I think it's the numbers.
I tried to find a comparable picture for my about slide.
Good stuff. Yeah, it lines up nicely.
So much. Thanks for joining in.
Sorry, Carl, just quickly, do you know if we need to actually trigger the recording ourselves of the session, or is it being videoed automatically?
No, you don't. You are live streamed as you speak onto YouTube.
Awesome. Cool. Thanks. Sorry, I hadn't seen you there.
It's okay. If you look at the text underneath the stream, there's actually a link to the playlist, and you can go down and you'll see the client's breakout is streaming. I'm watching it as we speak. So take it away, Connor.
Yeah, well, I'm not going to ask any more silly questions now that we're being live streamed, right?
Well, hey, I've already said that I was trying to come up with a picture that looked similar. So.
Cool. All right, so I'll try and make these slides just a bit bigger for the. Hopefully these will come through okay. Right, sorry, I'm going to stop this screen share and then start another one just so we can see everything. All right. Okay, cool. So hopefully everyone can see the slides there. Hope you get a thumbs up just from, yeah, we're all good. Okay, cool. All right, so we'll run through this deck, and then I think hopefully as we go through it, we'll have some opportunities to kind of stop and discuss and so on. And then I think that once we've kind of gone through the motions and everyone's kind of got some context, we can then start thinking about how we actually want to proceed and start capturing some more specific details about what we're trying to achieve here. So, of course, we'll start with the intros. So I'm Connor Svensson. I'm the founder and CEO of Web3 Labs. Web3 Labs is a blockchain technology company. We've been in the space for a number of years. We're responsible for the Web3j Java and Android integration library for Ethereum, also the Epirus Blockchain Explorer, and we've done a number of commercial engagements as well with various companies across the space. Also been very involved in a number of industry organizations as well for the past 3 years. So at the Enterprise Ethereum Alliance, I chaired the technical specification working group, which was really responsible for churning out the Enterprise Ethereum client spec that was first released a couple of years ago. Then this year I got involved with the baseline TSC because as is shown by the number of attendants we have here, like it's a very awesome premise, and I think there's a lot of people who believe in the potential of baselining basically on top of mainnet. So it's kind of a no-brainer when it launched to kind of get involved there. I'm also involved in an organization called the Interwork Alliance, which is looking at kind of standards for really business processes in the context of blockchain. So, creating standard ways to represent, processes that are well suited to DLT in a manner that's ledger agnostic. And then finally, as well, within Hyperledger, I'm involved with their climate special interest group there as well. I will now pass over to Kyle, who's going to be running the session too.
Hey guys, thanks Connor. Kyle Thomas, founder of Provide. Provide was created to blockchain enable enterprises that didn't have a clue about blockchain yet. And boy, did they not have a clue when Provide was created. It was early enough to we blockchain enabled developers, but we needed to make sure that we could blockchain enable the enterprises as well, because obviously they're the ones that employ the developers and make the decisions. Through my work on Provide over the last few years, we found ourselves in a unique position to contribute to the baseline protocol through the enterprise, the EEA, Enterprise Ethereum Alliance. We were able to get involved with the main networking group and then the imminent task force, which made a lot of sense. And so as a result, I helped architect the 0.1 release of the core protocol. Today we have a commercial baseline as a service offering as a result of that, working with customers like Kona, Coke One North America, and some other large international organizations on creating baseline offerings, and things are going quite well there. Also, I organize a ETH Atlanta, which is just an interesting fact. ETH Atlanta is kind of we've had 2 events. One hackathon modeled off of ETH Denver. That was back in 2018, and then just recently we had a virtual event that sort of featured the baseline, the usual suspects in the baseline community. Thanks, Connor. Back to you.
Cool.
Hey, by the way, Connor, I noticed that we don't have chat in here. That's my fault, and I'm not sure why. So something in the configuration of the 8th concurrent session seems to have gone wrong. Nobody else sees chat, do they? Inside the Slack or inside the Zoom?
No.
Yeah, sorry about that. I advise use the Summit chat and Slack while I try to work that out. Probably I'd have to kill the session to set that up, so that's probably not worth it. So, but sorry about that.
That's cool. So just in terms of the where are we? The for the actual chat. where was it? Wasn't there a tab across the top? So we've got context here.
Actually, there's not a tab across the top for chats, but anybody can put notes in here, and that's the whole point of the note section. Is just it's a scratch pad, right? Go to, if you want to make something permanent, put it into the Epic.
Cool. Yeah. Okay. So thanks, John. Yeah. So there's yeah. Let me just bring up the. Oh, where's it gone? Sorry, a sec. It's vanished. So I can also see there's a lot of yeah, good people who've joined the session here as well. So I think what will certainly be helpful is as people kind of pitch in and ask questions, it might be good just to kind of introduce yourselves and what it is you do too, just for the context of those people who aren't aware of you. I know we just because I think that it'll be certainly be helpful for those people who you know, aren't familiar with, say, Nethermind or, you know, Ethereum, or you know, involved in the baseline in some shape or form. It will definitely be good for those people, you know, to, you know, make them aware of these projects and what you do on them, because yeah, we've really got some key people here for this discussion. So okay, so fundamentally, the goal of this working group is basically to enhance the kind of client and language diversity we have for Baseline. And yeah, the reason for this, of course, is that you know, there's multiple Ethereum clients out there, and there's multiple languages that people, you know, develop in. As it currently stands, the sort of baseline stack, so to speak, it's predominantly written in JavaScript, and then it uses the Nethermind clients, and there's good reasons for that, which I'm sure that Carl and Thomas can, you know, will elaborate on shortly. But really, what we want to, you know, the baseline protocol is focused on having, you know, being standards backed, and so, you know, with any sort of technical standard, you know, the kind of the litmus test of the quality of that standard is always, you know, having multiple implementations to support it, because, you know, it ensures that the actual specification is robust enough that people can derive those other standards, and B, it just gives that, you know, that greater choice as well, so that, you know, if an organization is very, you know, they've got a lot of technical expertise in one specific, you know, stack, then it's good to be able to, you know, focus on that stack rather than, you know, forced to, you know, bring someone in with something else. And so really, you know, what's guiding this, of course, you know, I've got a lot of interest in JVM development on Ethereum, but you know, also the JVM and the .NET framework, they're very widely used in enterprise, and also, you know, we have a number of Ethereum clients that are kind of, you know, enterprise, you know, suitable for enterprise as well, because of course, you know, Nethermind we see has got great traction in the public network community as well as in you know, the enterprise community. It kind of, I think, Thomas, it's fair to say, kind of spans both, so to speak. But then, you know, Hyperledger Besu is certainly, although it is, you know, mainnet compatible, it's being pushed more as an enterprise one, and it's likely to become, you know, kind of the core part of Quorum in the future as well. So there's kind of, you know, in order to help grow the overall baseline ecosystem, really you know, I think the thought is that if people have the ability to plug other clients into the baseline that kind of suit their own internal architectural stacks, then that's going to be a better thing for the overall baseline ecosystem. And so the goal here is really to talk about, you know, how we think we would need to go about it in order to get there. Yeah. So if we, what we'll do is we'll touch on the current architecture, and again, you know, these slides are just kind of to, I think, you know, frame everyone's thinking before we actually go into the specifics. But do, you know, if you have any questions or want to speak up at any point, please feel free to. But we were going to run through the architecture and then just talk about, you know, how conceptually you could potentially break up the baseline packages, and then we'll, yes, then at that point we can start really, you know, getting into the specifics. So this diagram here reflects it's really the great work that Kyle and Provide did over the last, would it be fair to say, sort of 6 months or thereabouts, Kyle?
Yeah, 6 to 9. Yeah, 6 to 9 months.
So for context, the baseline protocol was initially using Geth as its client, and there was just kind of, well, I guess it wasn't as clean
and Whisper as well.
Yeah. It was more kind of created as a demo thing to prove a concept, as opposed to being something that was like a robust foundation. And Kyle and his team basically went all out for months to just completely turn it around, and did an amazing job here. And the end result is basically what we have in front of us now. I think for the context of this talk anyway, what we're looking at really is the fact that with the baseline, you can kind of think of it in terms of 3 sort of groupings of components, so to speak. In terms of, you have messages coming in via the NATS messaging protocol, and then you have your actual pieces where you're you're generating your proofs, and you're basically processing the messages, and ultimately then spitting something out onto onto a public Ethereum chain. And so those are kind of broadly speaking the actual pieces that we're interested in here, and it's how we can kind of if say we look at these pieces in isolation, so to speak, we can kind of see where there might be opportunities to provide greater flexibility there. So if we go back to the start, of course, NATS is a very well established messaging protocol, but you might find down the line that other enterprises, they want to use, say Kafka, or some real old school workhorse like IBM MQ, or something like that there. But then in terms of the actual the zero knowledge circuits that are used here, so it's using Socrates currently, but again there's areas there that we might want to support other ones, but also again provide other language support. And then here we have the persistence piece here as well. I mean, I think, Kyle, it's probably worthwhile you as well going into a bit more depth just for context around all of this, because you can really talk about how it's evolved and the changes that have happened there. And I'll move this around as to kind of support you.
Sure. Yeah, no problem. Yeah, I think it makes a lot of sense, sort of to piggyback on what you said about how we need to look at the entirety of this effort, and each of the parts in isolation represents an increment or an iterative step that could be taken in terms of client development. And huge shout out to Tomasz and Nethermind and his team for the work that they've done as well to make this possible, right? To make this architecture possible. I think the real driving, and as you said, like the Radish 34 proof of concept, it used Geth, it used Whisper. There were a lot of shortcomings and hacks to it. It was a great proof of concept, and based on that, one of the big things that I noticed was that it was using a Timber service, which is an EY blockchain project that stores Merkle trees in a database, and essentially that was decoupled from the Geth client. And I thought, it makes a lot of sense if it weren't decoupled from the client, if actually the Merkle tree database was lived behind like a baseline RPC set of methods, or like a baseline RPC module, and that first module. It makes sense if we allowed users to track shield contracts, Merkle tree per shield, if you will, on the client itself, because the client is already getting all of the headers and processing all of them. So why do that twice? That just increases bandwidth usage, and it's more inefficient to do it twice. And so that's sort of where the iBaseline RPC core interface in the API core API package was the motivation initially behind it. I thought that, hey, that would really clean up the architecture a bit, because we would remove one service. We already have a blockchain client. Why not consolidate the Merkle tree onto it for efficiency? And so that's sort of where things started. And I think that's kind of the first that would be the first step, you know, in thinking about a new client implementation or you know, a client implementation generally. And Tomasz can speak to this too. You know, if you think about like Nats, that was the replacement for Whisper. So there was two issues. There was the fact that Get was used and the fact that Whisper was used. And Whisper obviously has since been deprecated. After the decision was made to sort of deprecate it in the baseline protocol, it actually was deprecated officially. It's no longer being worked on. So Nats though is fundamentally different than Whisper in that it allows us to do true point-to-point messaging, where Whisper is a gossip protocol, and it's more peer-to-peer. And there's subtle in the nomenclature there around point-to-point and peer-to-peer, but like there's quite a big difference. And the privacy aspects of peer-to-peer messaging and the gossip protocols, while they're useful for many applications, you know, sending notifications to counterparties in a business process is not, I don't believe, one of them. You really need to do that off chain. You need to be able to connect directly to you know, your counterparties and deliver those messages directly to them. You use the org registry contract to look up their endpoint, and you know, there are public keys associated with each entry in the org registry, and you know, AKA the phone book. So that, like, Nats lended itself well as a replacement for Whisper. I think there's, you know, opportunities to bake Nats into the client as well, and then it's something that Tomasz and I have been talking about. Tomasz, I'll pause here and let you weigh in. Is there anything that I've missed here that you'd like to correct me on or chime in on?
No, I think it's straight to the point. So it's all about the efficiency and streamlining, like the flow of tracking the data, of exposing the data in a very familiar way for all the Ethereum developers, people who have been building integrations with Ethereum clients in the past. So providing the same experience for talking to baseline as you used to talk to Ethereum clients in general when asking about transactions, blocks, and so on, should make it much simpler and just like change it even slightly better towards very quick, rapid integration with the systems in the enterprises. And together with the Provide platform, everything that's in there, with very quick synchronization times to keep adding the nodes and making sure that like you don't have outages, that everything actually works the way that makes this baseline mainnet experience very smooth.
Thanks, man. Connor, I think that do you have anything to add, Connor? I guess I'll turn it back over to you.
No, all good. So in terms of the actual components, and this is where we've kind of, you know, try to just, you know, high level kind of think about, you know, if we're trying to break down baseline, like, you know, previously we have the kind of sequence diagram that shows the different flows, but then in terms of the actual, you know, considerations of you know, what each of the components do and what their responsibility is, we've you know, grouped them together here, and so hopefully this is all fairly self-explanatory to people. And you know, please as well, if any of this stuff isn't clear to anyone, you know, don't hold back from answering questions, because you know, we'd much rather have like an interactive session where people are saying, well, you know, why do you do things this way, or you know, why is it like that? Because although there's, you know, the people who've written a lot of this stuff are here, it's really helpful if we can, you know, educate people as we go as well, because you know, it's hard often trying to do this stuff if you don't have someone to ask the right questions to. So I really do want to encourage people to you know, stop and ask any questions, however you know, mundane they might feel, or you know, whatever else. so yeah, just chime up. But yeah, so as we've mentioned there, there's the actual client itself. And then we have the smart contracts basically that are used by Baseline, and that's yeah, that's there. Then we have the actual privacy circuits as well, which are used for the the zero knowledge the zero knowledge proofs, the actual API as well. There's an organization registry, the messaging piece, then standard kind of persistence, but then also the kind of privacy layer that uses the privacy circuits behind the scenes, and a example project as well. Does that kind of make sense to everyone? It's like what this actually looks like. To help contextualize it as well, we can we can show you on the actual Baseline repository repo. If I can figure out, yeah, there we go. You'll if you have a look there in the code too, you'll find that the actual modules kind of they're not perfectly aligned with that, but they are kind of similar in that you have your Socrates circuits there. You have an example reference. You've got the core piece, and this is where you've got like the API contracts, messaging, persistence, privacy, and there's also additionally types there as well. But the point is that we've kind of broken it down, being led slightly more by the code here as opposed to just going with the conceptual part, because what we're trying to do here is think about how we could actually move this forward. Okay, so I'm going to see. Okay, so and this is like a one potential approach here, but I think it's good to highlight this, and then we can start the actual session part going, where we can start going into a few more details. So what we could potentially look at breaking this down into a few phases, where you have your actual blockchain client piece, where you select a different client, and then you say, okay, well let's make sure that we can run the core contracts, plugging in with Besu, and then update the example project so it supports that. And I'd propose anyway that that's kind of like I suppose the most minimum first change you could do to at least validate it there. Now I know that because of things like the Merkle tree that's used by by the actual protocol itself, it's not like it would just work out the box right now, and it's probably going to be useful to jump back into some of those specifics there. But at least if we we can kind of frame what things would need to be done, then it's going to provide a bit more information, so when someone does want to take on this task, they have kind of a clearer direction to head with it.
Question, Connor.
Yeah. I introduce yourself as well, just because.
Hi everyone, I'm Juan Blanco, created Ethereum. The idea is the .NET to help on the .NET integration on Ethereum. Originally it was a client, but I left that alone. So on the questions on the Merkle tree, and then because the idea, this is going to be the integration directly with the public mainnet. Is that correct? So targeting just Besu might be an issue, and we probably will want to talk to the Geth guys as well, and just to kind of put that prototype or as well. And also I was thinking in areas like optimism or layer 2, as we might want to consider that a layer 2 might want to integrate to and put that data there, which later on might be put into the mainnet as a roll-up or so. Yeah, those are the kind of so it's mainly like just not to because it's enterprise, but it's not enterprise because it's connected to mainnet. We need to consider other areas as well. your the screen is showing kind of. And you're muted as well.
You're still muted.
You're still muted, Connor.
I was just saying, yeah, it's hard to keep all this stuff in my head. So maybe if someone can just add like a placeholder into the Google Doc for now, because I have a feeling if I hit something here, it might stop the presentation, and I don't want to disrupt things just yet. But yeah, to your point, Juan, I think that definitely the layer 2 question is an interesting one, and I'd love to know if that's actually come up before, because it's I've not heard anyone talk about that, but I think it's very relevant. But the other is I think it would be really good for Carl and Thomas just to give the perspective on why Ethereum's being used, because originally Geth was actually being used in the first proof of concept for baseline.
So I'm sure. As often, we have this confusion of names. So Juan is actually from Ethereum, and Nethermind is the client name. Why it's used, I think, to add choices, to add possibilities. So we could, we always were thinking that .NET Core as a technology for the client is very enterprise friendly. So many enterprises already have lots of .NET developers on site. There are integrations libraries to Ethereum, like Juan's Ethereum. It's a fantastic tool to just connect with the Ethereum clients. And if you have also the client that you can expand by adding plugins, by feeling familiar with the code, and many enterprises will be more likely to feel familiar with .NET than anything else, then it's great. And then when you actually make it like baseline native in a way that adding JSON RPC interfaces, tooling, that is for baseline, by integrating with a fantastic stack from Provide, which makes it easier to deploy everything together, to launch it. Then this is what enterprises should like. They'll feel like they have all the tools needed, that they can start faster, and they can start thinking about their business, about the processes that they want to automate, and not necessarily like be worried about the technology itself. So I think this is the way.
So, in a standard perspective, was mainly as an enterprise, I might want to go and check what has happened, on the mainnet. So without having to rely on a third-party vendor. So you think later on, maybe you got DeFi coming along, and then you just want to link a proof or something to a specific token, about etc. Yeah, not gonna explain the use case. So you want to just verify on chain. It's like, okay, this is in here, so I want to connect, and then just mainly connect to the smart contract and so on. That's why I kind of driving on the standard of the client. So mainly you just create an API, I create my application, etc., and start doing whatever you may want to do on mainnet. It's another use case. It was expense of the as more and more enterprises start using baseline, you might want to use the layer 2 just to reduce the cost, and maybe it's another step, might be other complexity, might be not be required, but you might want to use a rollup to do so. And even if baseline is like in a rollup in Sun, so you may do a rollup and a rollup. So those were the ideas. But as a product, if you want, I understand, as a normal enterprise, you say, hey, I go here, everything, I just roll it up, and then I can connect, etc. I'm just thinking more like for external parties who, when I don't know, you're doing starts in doing invoice factoring or whatever, you want to tokenize something and you want to validate that the proof as for something that is real and it's been validated. So yeah, the starting points on why everything could be rollup and why the idea of using Geth or optimism or whatever.
Yeah, no, so I think yeah, so I mean, so certainly this idea of you using roll-ups is just yeah, I think that's a very valid point, because certainly I know that John Walput's been doing some kind of some high level calculations about the transaction volumes that they'd want to support, but yeah, I think given that in the next pre ETH2 shards anyway, which we're looking at least 2-3 years, it's roll-ups is kind of the scaling solution, right? So it's yeah, it seems like sorry, excuse me, a good place to be. Just on the subject of the actual clients as well, I did see that we had is Anais still here, or maybe she's dropped out. Up until a few minutes ago anyway, I thought we had, yeah, we did have Anais here, but she's not here, unfortunately. The reason I mention her is because she's working on the kind of baseline standard specification, and to have kind of that more generic interop for different clients as well. Of course, we can work on an additional client, but also having standards to kind of make very clear that these are kind of, this is what they need to support, i.e. what Nethermind does right now for baseline. So yeah, I guess was this something to follow up down the line with her and the standards works that's happening there, but that will certainly be one way to make it clearer, what the paths would be if subsequent clients wanted to come on. I think that's such as whether it's Geth or Open Ethereum or anything else. Yeah, so then really the other part. Oh, Anais is here. Anais, are you there?
Yes, I'm here. I just came back. I need to talk for a moment. Sorry.
Ah, that's okay. I wasn't sure if you caught any of that there. Did you hear any of what we said just now, or
I just came back. I'm very sorry for this. Yeah.
No. I saw you were here, and I thought it would be great to get just to your view on this, because you're driving a lot of the standards work right now. And the question here in terms of what we were discussing was, right now the baseline protocol has Nethermind as its kind of client that it supports, but with the standards work that you're leading within the group, is there anything at this point in time that's looking at what are the interfaces that a client actually needs to support for baseline? Because I'm not across all of the work that you've been doing.
Yeah, sure. So yes, so it's basically the second standard. So we are looking at interfaces and data model, and both like internal and external as well. So the way we have approached it is really to focus on what are the category of interfaces in terms of what are the capabilities that they deliver. So if we focus on org management, for example, and we focus on iRegistry, what are the functions, but also in terms of the data model, what are the key entities and the relationship between those entities? So different clients will have very clear specifications about how all of those should be, or must be, I should say, must or should be implemented. And we have started the work. And a lot of the API work actually is inspired or is built upon what was released in v0.1 anyway. Now, seeing that, there are definitely areas of improvement and things to be discussed. You mentioned Socrates for privacy circuits, but Socrates, if I'm not wrong, only supports zk-SNARK. But do we want, from a standard point of view, to really limit and be prescriptive about the utilization of what type of zero knowledge protocols? The answer should be well, no. So we should abstract. And rather than focusing on the zk-snark related interfaces, which are currently in the different reference implementations, one discussion that we could have is it possible to abstract even further those interfaces, as an example? So we ensure support for other types of zero-knowledge protocols. On the persistent side, it's not currently in the reference implementations, but I know that Kyle and teams are actively working on that. So once it will be, yes?
On which part? Sorry.
Persistence, the high
Yes.
persistence service. So
Yep.
once it will be pushed to the repo, we will basically go through it, understand what are the functions and what are the entities that power this entire interface, and start the conversation on the standard side from that key point. So our cycle on the API and data model side, rather than on the core side of the protocol, is always looking at what is the existing implementation as a V01 of the different reference implementation, what is currently from a client point of view, what has already been implemented, and we discuss from there. So it could be that as more work is being done, some changes will happen in, at the interface level or at entity level. So we need to, to take that into consideration as well. The goal is that, as you said at the beginning, it should not matter what the implementation solution is in terms of languages, in terms of all of this, as long as those key requirements are implemented to ensure interoperability, we should be fine.
Awesome.
So the persistence package as of today actually has a skeleton in there on IACE if you want to look at that. There's some stuff in there.
Okay, yeah, I will definitely look at it.
So if you just bear with me one moment, I'm just changing rooms quickly now that.
Yeah, sure. Actually, I do have a question while you are changing room. When we discuss the core contract, so for the first implementation, the Shield contract was really one of the cornerstone of the implementation, right? But now we are going and well, as we are progressing, we realize that we may not need the Shield contract. Again, I'm speaking from a standard point of view. There are different shielding mechanisms. And the usage of a Shield contract is one implementation of those. So this is a type of, when we think about approaches for, from a standard point of view, we always have to come back to the question is, how do we differentiate between the implementations that, yes, allow us to start the conversation in terms of what are the must-have and should-have specification versus like recommendation, like guides. This is what Nethermind has done. This is how they've done it to date, etc. Does that make sense?
Yeah, from a standards perspective, I think. Yeah.
Sorry, right. All set. Thank you for those additions there as well. It's yeah, as Annie says too, by having these further abstractions, it's kind of the natural extension to be able to plug anything in there. But moving on from this slide, it's kind of super speculative here, because what we're saying is, okay, well, say if we plug in a different client and it works with the contracts, we've got an updated project, then do we want to start looking at then trying a different sort of swapping out the actual privacy circuits that we're using, and here's where maybe we don't want to go with was it ZK snarks? Maybe we want to start looking at Starks, or some other zero knowledge technology, but having that flexibility there. Yeah, so then and then finally, you know, we can get into different you know, persistence modules and messaging formats. But again, if there's, you know, if the specification kind of moves faster than the code, so to speak, then there'll be some natural abstractions there, which would already end up being implemented in the code. So it would make that kind of you know, chopping and changing a lot more straightforward. Sorry, I faced you twice. So I mean, the overall, you know, next steps here anyway that you know, are being proposed is that, you know, we have a an issue created, and there's also the hackathon starting as well. That will be 2 weeks and 4 days. You know, for the baseline protocol. So you know, what would be a great output from the session now is if we've got enough information there, so that, you know, if someone decides they want to take on this task during the hackathon, then we can actually you know, they've got a good starting point. That's kind of the output of the session that we've had just here. So what I'm going to do now is I'm going to open up I guess the collaboration space, so to speak. You know, the kind of shared doc that we have, so that we can, you know, well, start collaborating basically on this. Right, so can everyone see what I have open there? I'm going to reshare the screen just so that it's so that it's clearer for everyone. Just one moment, I'm just going to find where my Zoom controls have gone. Oh, where's it gone?
What control do you need, Connor?
I'm just trying to because I've plugged into. Here we go. No, it's just my.
Okay.
So sorry. Was it just my desktop showing there?
We see a beautiful island.
Yeah. Okay. Yeah, I had the same thing happen when I was on a call the other day. So what I meant to show. Let me just finish. Show these slides again.
I have the same desktop.
That's it. How many people haven't don't get around to changing them each time Apple release a new release of OS X. Right, so I was just kind of wrapping up the last couple of points here, which was, you know, we were talking about a roadmap with the potential approaches, and then, excuse the typo here, we've got phase 2 twice, but you know, there's the potential for subsequent phases where we look to actually have different you know, components that we kind of swap out, because although we're talking about clients and languages here, there's no reason that we can't kind of then move beyond it to start provide greater flexibility for, I know, the messaging layer, the persistence layer, like the, you know, the circuits that are being used. Yeah, and so that's really what that's getting to. But then the next steps is that we want to have something ready really for the hackathon, so that there's a way for people, if they want to get involved in this and use the hackathon as an opportunity, there's somewhere for them to start, and there's enough reference material that it becomes, you know, helpful. Right, so I'm going to now share the correct window, and we can, I guess, the more collaborative part of this session can now start. I presume everyone can see the you know, has access themselves to the actual the Google Doc here for notes. So what we have in here, again, it's, you know, there's not much in there right now, because the point is that during this session we're going to start putting more content in here. But what we have included a reference for is the actual the GitHub epic that's been created. So this is something that exists in the public baseline protocol GitHub repo. So there's you know, no one should have any issues accessing it. But really what we're doing, what we have here is just you know, kind of fleshed out some of what's being discussed here. There's not really any more information here, but at least this epic can kind of be our you know, our reference point for then the subtasks that get created, which could be the items to look at for the actual hackathon. So I'm not going to spend you know, time going through that, because everyone has the same thing in front of them. But I think what we will do is just start going into a bit more detail. So if we were to First of all, I mean, what in terms of people who are here on the call, you know, are there specific areas that, you know, you'd really like to, you know, sort of be prioritized here? You know, what we've done in the slide deck is we've just suggested something. You know, we've just suggested, you know, you could look at taking the blockchain client and, you know, creating a new example project that uses that and make sure that the core contracts work with it. You know, is this a sensible initial approach? Because you know, this is kind of just off the back of some discussions that Kyle and myself have had. It's not that, you know, there's been a big consensus or a big group of individuals saying, you know, this is the area that, you know, we think would be best to start. So, you know, does anyone have any opinions or views that they'd like to share here? Sorry,
I have more of a question. So from a standard point of view, and sorry, I'm looking at everything through that lens today, but if we think about portability as one of the key issues, well, not issue, or one of the key objectives that we need to reach, is there, what would we think is are the components that we should focus on to ensure that a client is able, or I should say a company baselining is able basically to port their existing business process and data from one client to another? Like, this is really, from a business point of view, the type of question. And then technically, what are the key components? How do we prioritize those components and those type of things?
Yeah, I think that's a really excellent point to raise, and is just in terms of the portability kind of help frame the thinking. So I've got the actual session notes in a separate window now, so I can update them as we talk here. So
and I'm not the best person to answer the question, but what will be the most problematic component out of the list that we see here that could cause significant issue with portability?
Yeah. Okay. So yeah, over to the floor. Does anyone have something they'd like to start with in terms of their views? I mean, let's do it this way, so it's not being you know, not being tainted by what's been suggested so far.
Yeah, I think the iBaseline RPC interface would be an interesting place to start.
Sorry, so say that again, please, Kyle.
I think the Merkle tree, the baseline RPC interface. I guess that's sort of part of the API implementation component, or maybe we consider it the client. It's like a combination of the client component and the API implementation component. I think that would be a good place to dig in, probably to start. Yeah, and Tomasz can give some good insights around that.
Can we establish the requirements so they can be matched to the standards track that Anais carries? So mainly, why this requirement of the Merkle tree, what other blockchain, you know, even, you know, what we do everything in Ethereum will need to do. And probably that translates to a layer 2 implementation. And yeah, just trying to, if it's a full requirement, what's the requirement, what does it do, what's the how does it get implementation, and then they can be mapped up to the overall standard of baseline that Anais can document it. Hopefully that makes sense.
Yeah, there's already a section of the standard that describes the baseline RPC. So this is the one that is consistent with the implementation for the reference implementation 1. And it will be evolving, but just slightly. So we're introducing a few wrappers around the things that are there. And the interface itself will be very familiar for anyone who worked with the Ethereum JSON RPC. So we we take the same approach. We treat the block parameters exactly the same way. The way you receive data is consistent with all the standards of Ethereum.
Okay, so I have a question. So one of the function on the A baseline RPC is the deploy function. And my understanding was that it's supposed to deploy the chill contract itself, right? But my point was...
So we actually, sorry, go ahead.
No. So it's a question, because if that's the case, this is where we have an abstraction issue, because if we, from a specification point of view, if we say it's a must-have that a client implement the I baseline RPC, but then we tie this to the deploy function, deploy a shield contract, when at the same time saying in the other standard, so the core specification saying that shield contract is not a must-have requirement because this is implementation specific, this is where we have a discrepancy. And this is
in the standard, I would agree. So one thing to note, that the deploy function actually is already deprecated, and we've been using baseline track. That's sort of the key. I'd say that's the key. Right now, because you like, in terms of the standard itself, yeah, you're right. It's too implementation specific. Yeah.
So the track, what was the function you said that is replacing deploy?
Well, it's not replacing it. It's a baseline track. So like, but again, track is a lot more abstract, right? Like you can think of that the track method to apply regardless of whether it's a shield contract or trusted execution or some other privacy mechanism, right?
Okay, okay.
Does that make sense?
Yeah, yes, it does. So
yeah, we were using it before. Yeah. We were using baseline deploy and baseline track, but now we're actually just using track after, like, we deploy the contracts, and then we call baseline track, which is really what initializes the Merkle tree database and it begins listening for updates on that shield contract.
Okay.
So deploy should be treated as a tool for diagnostic. So any enterprise before going mainnet that can use deploy for very quick, rapid testing of the private chains, where they can deploy some built-in, standardized, simplest implementations of the Merkle tree and so on. So it's not part of the requirement for the clients. It may be treated as some additional tool within the same namespace that is available in Nethermind, but not really part of the standard requirement.
Okay, it clarifies a lot. Thank you.
So can I ask if someone can put the links to the relevant parts of the specification on the Google Doc, because I think that will certainly be very helpful just to make sure everyone's clear on this. And if we could do it kind of right at this point, so that people can open it up, because then at least it's easier to follow the discussion.
Yeah, yes, sure. So one thing is that, as I said in the opening session, we have the building blocks and the high-level requirements, but in what you will see is just a draft. So I will include the link now. Requirements. So it's not set in stone. I just want to put a big disclaimer here. This is work in progress. So okay, I will look for it and put in the Google.
Yeah. Hey guys, I need to jump. Connor, I just want to say thanks for facilitating this, and I will circle back to this session and see what kind of notes and action items come out of it. But yeah, thanks again.
Awesome. Thanks, Carl.
Cheers. Okay.
So what I would like to do though is just actually where I'm trying to get to here is that we can actually we can have some notes that can then make it into the actual GitHub. Can be created as a GitHub issue, so someone knows exactly where they need to look here. What I'll do is if we open up the actual the link that Ines has given us, then make sure that everyone's kind of clear. So is it basically this the baseline RPC calls here?
Yes. So this is what we have started working on, but well, as per this conversation now, so disregard deploy. So first of all, the structure of the document will change. So this document, the API and data model, will focus on all the interfaces, their description, and we will need to provide a caveat. And then we'll have the data model. So for each what we call requirement categories, for example, messaging requirement categories, persistence, or org management, what are the entities? So work groups, user, organization, those type of things. So this is our this is the type of content that will make its way through the this specification document.
Cool. And so in terms of Thomas, just so that kind of everyone's clear here, what you did basically was that you extended Ethereum so that there was this additional JSON RPC API basically that could be it could support, so you could actually have a Merkle tree that was accessible to something, well, accessible to someone who wasn't a process that's not actually running within the client. This is obviously typically the case with Ethereum clients.
The client is Nethermind. We are both smiling with one here because I think we both very often.
Yeah, sorry, my bad. Sorry. Did I say Ethereum?
Yeah, but like it's always an honor to that great tool. So that's cool. We're trying to keep making sure that both tools are equally great and going forward and provide for .NET Core community. So as for the extension, yes, we even made it like a plugin. So it's the baseline itself now can be just dropped into the Nethermind directory of plugins, and it adds a few components to Nethermind. It adds the CLI extensions for some more like diagnostic developer tooling. It adds the RPC methods that you see here. And as mentioned before, the deploy one can be treated more as a rapid prototyping locally within enterprises without connecting to mainnet, spawning some in-memory database and testing how it behaves. It also adds this like a tree tracker. So there are like two types of interfaces in Ethereum that are within JSON RPC, and the one related to baseline here behaves a bit more like if subscribe or the if filter logs on Ethereum. So it actually creates something that spawns additional processing on the node. So it tells the node that it should start serving information about the baseline trees. And when you start tracking the baseline tree, you will have a much faster access to proofs, to verification, to extracting data from the tree and pushing the data to the tree. Apart from that, what we work on as well is a set of network and sync extensions to simplify the process for the enterprises to sync quickly, like to use the fact that we have NATS infrastructure at hand, that we actually talk to enterprises that already pay for data storage and can serve us that data much quicker, while we still have the notion of trustlessness and verification of everything. We can actually, instead of collecting the data slowly over the network, how it is on the public mainnet, I mean, we're still on the public mainnet, but we can actually speed up some processes. And it's very similar to multiple approaches from various clients on Ethereum network now to either use BitTorrents or other sources of data. Within baseline, within Nethermind, you can actually sync mainnet a bit faster soon just by using those solutions and using also provide infrastructure to support it. So yeah, I think this is all that's coming with baseline, and the additional configurations and the extensions that make the Nethermind and provide stack much closer. So we've added solutions to use Nethermind client and use the transaction payments API, broadcasting of transactions via provide payment systems. So you can spawn a Nethermind node. You can send a transaction there without the signature, without holding private keys, without defining gas information, without paying for the gas, and that transaction can be sent to the some of the components of Provide stack. So the vault that handles the secrets, so private keys and so on, the account management infrastructure, and the gas payment. So the transaction is actually covered for you, and you can work with Provide to do the payments processing. Like so you no longer have to worry about gas, about private keys. And these are two things that usually with enterprises are the most problematic. First of all, why do I have to hold ETH that is highly volatile and still a bit unregulated when you think about what your accountants will say, what your compliance will say. So that's one thing. And the other thing is private keys. It's like, it feels expensive, problematic, and so on. So you want to have some custodian for the keys. All of that comes together, and not all of it is part of baseline, but it's part of that work that we've done as bringing various companies that work on baseline to deliver better experience.
Yeah, this is really, really helpful. And with the actual Nethermind docs as well, because of course that's, you know, they're probably complementary to what's in the specification right now. Is there a section that talks about some of these extensions? Because I was having a quick look there just to see if we can stick in a reference to a specific part of the documentation. Again, it's just for the picture of completeness in the actual Google Doc that we're
sure, I'd be happy to share the one link to the maybe not only, but like somewhat slightly outdated version of the docs. But I think you could still use it for spawning the entire baseline process locally by launching two Nethermind nodes that create in-memory networks and making them deploy the trees and start talking to each other. It's not a perfect flow, and I think soon we'll follow with more detailed one that includes the flow with Provide, with setting up things, with connecting to mainnet. But I can share it here now. I mean, we don't have chat, right? So
yeah. So if you stick it in the we have the actual notes section here, and so we can get rid of that. But yeah, if you stick it in here, then at least it's something that can be captured.
Okay, I have it. Yeah. So one moment.
So to try and kind of sum up what's been discussed so far here, really, in terms of the in order to support a different client, the main consideration is that that client can support these additional JSON RPC API calls. I think that would be a fair assessment of what's been said here. With respect to Juan's question earlier on and points about making use of actual layer 2 chains as well, and this is more a question just for the specific to the actual JSON RPC API. Do all of the kind of the transaction capabilities go through this kind of same JSON RPC API that we've mentioned here, or are there some other routes that they actually go in? Because this is obviously used for the Merkle tree, but then there's also transactions happening as well.
Yeah, that's much nicer, because actually the transactions are using exactly the same APIs that are already in Ethereum. So when you call Ethereum and when you want to broadcast transactions via Ethereum node, you will call ETH module, which is exposing two methods. One is called send transaction, and the other one is called send raw transaction. So one is a transaction without signature that assumes that your node somehow handles the signing and adding signature, the private keys. The other one is just pushing to the node transactions already signed and ready for broadcast. So the latter doesn't change at all. The former, the one that requires the node to handle your private keys, allow Nethermind to forward that responsibility to Provide. So this is this enterprise flow where you push the transaction that express what you really want to do with the transaction, and that transaction is wrapped into the gas payment and distributed. But you use exactly the same API. There are no new APIs added at all. It's just a matter of configuration of the node itself.
With the does baseline in its current state anyway, use one over the other in terms of send transaction or send raw transaction?
No, it's like it's all freedom of choice. It's if you want to pay for the transaction yourself, if you can manage private keys yourself, and I believe some companies will want to do that. They're totally fine to use the standard flow with the transaction pool and broadcasting. What we say here is part of our work as working together with Provide on baseline, but it's absolutely not necessary part of the standard. So this can be done a different way.
Yeah. Okay. So to answer the question that Juan raised there, then as long as these layer 2 scaling, if the layer 2 scaling solution presents a standard JSON RPC API, then it wouldn't be problematic at all to work with it.
I believe so. Yeah.
Oh.
So in a way, what they will need to implement, obviously you need to have the Merkle tree, the storage, that will need to be synced across different nodes, or just a specific for performance. It's just a single node that's to store the data for performance. Okay, and then you as per what you have said, send transaction, which will be normally used when you have your account unlocked or something like that. You mainly, in the same way that Quorum works, that you have your authenticate with your account or something, that will delegate the payments or whatever. Well, but obviously that will be done in a private network, so it's not like you opening your node to everyone to use. Right, yeah, like and obviously the bold element that provides
the private network. It can be public, but because but if it's your node, the configuration that the node has includes the access tokens for Provide network, but there is no private network here at all. Everything is on mainnet, on public Ethereum mainnet. Yeah.
Oh yeah, but it's kind of it's a node connected to public chain, but it's hosted privately. It's like connected to Infura in a with username and password kind of thing. Yeah.
In what when you say connected to Infura?
We connect just for everyone listening. It's like it's a public node, but a specific public node that's configured to manage your transactions. So you can use you just mainly use the transaction with your details, and then the payment will be.
I mean, like probably for any Ethereum node on the public mainnet that you would host, obviously it would be publicly visible, but the JSON RPC itself would be just private for you. So you would ensure that the firewall protects it. So the same case is here. It provides some additional capabilities to support you with the standard queries around baseline and potentially the transaction orchestration extensions. But it doesn't require a setup of private network or the special tokens or anything like that.
Yeah. Okay, yeah. See, that's a very nice explanation. It just simplifies the baseline orchestration and work using a public node that connects with your enterprise.
I think the best intuition would be when you think about Ethereum nowadays, obviously very often you'll be asking about the logs, right? So you'll call if get logs. And in a way, you don't. This interface is not necessary for the node to exist, right? So you can always listen to the blocks incoming, extract the logs yourself, index them on the side. So what baseline RPC does, it's a similar work. It it handles for you all the events that are very specific to baseline and simplifies for you the querying methods. It provides you already with the storage, with extraction, with verification of those things. You can write them all of them on the side, and they're like not necessary for the node to operate, but they do just a lot of work for you. You don't have to do that yourself.
Yeah. And in a similar way as the seal, this is the standard contract. Anybody who who connects to a get client, back to the get example, they can just build all the Merkle tree themselves.
I guess for sure, yeah. It's exactly by repeating our work they can do that on GAF as well. Yeah.
So that could be kind of part of the standard as well. Just trying to build as you may need, to. And that was my point originally. As you may need to verify that the third-party provider that is sending you transactions is actually telling you it's an audit capability. Making sense. So you might want to go to another node to verify that the data that has been provided is exactly the same as the one that provided you for a normal service.
I mean, you mean the baseline data. So obviously, if you host the node yourself, then you can that data is extracted directly from the logs and like processed for you additionally.
Oh yeah.
When you say.
Yeah, so mainly like imagine an auditor coming here and say, okay, and so you might know, thank you very much, but I'm gonna use my other node that doesn't have these specific RPC capabilities because it hasn't built this Merkle tree already, but I can go to the smart contract, the seal smart contract, and build the
yeah. You can go to the smart contract, extract all the historical logs, build the tree yourself, and do the yeah. So that's the baseline in this way uses mainnet for storing everything, and there is no like magic data stored outside apart from what businesses keep as private theirs and just push to the network as commitments. But apart from that, there's nothing stored off chain that will be critical for the chain to work or provide you the data.
Yeah. That kind of is simpler to explain to people as well. So on the layer 2 scenario, in a layer 2 scenario, that kind of will be slightly trickier. So let's put the Nethermine as the mainnet node, and then you have a Optimism as the layer 2. So as it supports the seal smart contract, and so as a user can submit the transactions to Optimism, that will be rolled up eventually. Events won't be triggered. Because you're doing a roll up and then you just mainly storing state. But you didn't store this. You just store the call data, and then that later on can be verified in the roll up, etc. So in that scenario, Optimism on its own will need to, if you want to provide this mechanism, will need to validate it itself. And for a third party to audit the mainnet, obviously they don't have access to the seal smart contract. We have to go through the Optimism layer, layer 2 layer, or rebuild, even more fun, all the data of using the input in the in mainnet, and then right, okay, I won't go, but just just thinking of the problems. But yeah.
I think that so Optimism will not will not provide you the state updating transactions, but it can actually provide you with the list of call data. And by using exactly the same rules, you can in a way on layer one, by having those baseline extensions, start acting as a verifier of what the optimistic rollup pushes by just running those and checking as baseline participant, checking if everything makes sense. So yeah, you can do that.
Yeah. Mm-hmm.
Okay, so I think we certainly, over the course of the session so far, we have clarity on what would be the right next steps, and I think what's great here as well is that it's very clear that helping using the specification to help guide this is going to be very, very helpful and make life a lot easier. Did anyone else really have anything else that they wanted to bring up or discuss, or any other thoughts? Because I think in terms of what we've set out to achieve with respect to this session was figuring out what the path forward would be, and I would say that we are there basically. And then of course you can follow the specification to to try switching to a different client. Then probably the sensible step after that is to look at using a different circuit, and then after that you can start chopping and changing the more kind of mundane pieces, such as like your persistence layer, your messaging layers, because these are sort of very well established. They're not kind of areas which people won't be so clear on how they could go about it, or if there would be any technical limitations as such. Whereas certainly with the clients and the actual zero knowledge circuits, these spaces are evolving a lot, and so it's not something that we can take for granted that you could just pull out one thing and put another one in the same way that you could take NatSAD and switch it for with another point-to-point messaging protocol, or switch from one persistence layer to the other. So was there anything else that anyone wanted to cover off or use the session to discuss now? Because we do still have 35 minutes. Again, if there isn't anything, then we don't have to keep the session open either. But I'd love to put it out to the floor there. Alternatively, if anyone has any questions along the lines of why is this like this in baseline, I'm sure this can be a chance to talk about that as well.
Another question, as we were talking about different components, it's not a question, it's a general comment. As we progress through those and then explore different alternatives, we should have these conversations as well, like in the similar kind of submit. I think as more people get interested, they will bring more ideas to the to this. We're like talking about messaging. We were talking the other day about it could it could be, if it's gonna be internal in Azure, you could do like the Azure message posts, etc., or quick communication. If you maybe if you're using external devices as well, so there are so many scenarios on the messaging side, so that's kind of key on the standard element, but I think we'll discover as we move along, and we have different proprietary needs as well, like I said, with IBM and then all enterprises, as well, which will definitely won't have or won't move the enterprise messaging mechanism because they won't make sense to them. So that's going to be interesting. Connor, you've been doing a lot of messaging in the past. You probably can add a lot of that in here.
Yeah. Well, I think John Walper, constantly talks about make it all as boring as possible. So it looks like a normal technology, not something shiny and new, which is harder to, just always takes longer times for adoption in enterprises.
Yeah, but you still need to have that carrot on the stick. Like, hey, I want to put investment in here because obviously it's gonna return me all this, improve my messaging. But later on, it's like, oh, look at all this new disruptive technology that can join into it. So I keep saying that's the non-boring part. That's where the huge ROI will come later on. Yeah.
Cool.
But yeah. I think just covering this for now is fine. Messaging will come later. Anything that you're gonna be joining? Just keeping the chat going. And Deeds and the company phone book is going to be very interested. Well, Deeds as a possible implementation for the company phone book.
Definitely, and there's in terms of the actual sessions, there's trying to think when it's actually taking place. There's a session on the global phone book problem.
Yeah,
project. So it's a project rather than a problem. Which is coming up. But yeah, look, I think unless anyone else has anything else, now's a good time for us to wrap this session up. I'll type up just some of the, just we've kind of got the core information here, but there's a few further, we want to ensure that there is this kind of actual output from this, and so we'll just summarize what we have in the notes here. And then we'll let everyone jump off and go and join in with one of the other sessions if they want, or get on with whatever else they wanted to do with their day. So firstly, just quickly thank you to everyone for who's been here. Special thanks as well to Thomas, because you kind of I think Kyle pulled you in, and it's been really valuable to get your input here. As well, Anis isn't here, but she's been doing a fantastic job with the specification. Kyle, of course, the work he's done on baseline, and also the work that provider doing, as Thomas pointed out too. There's some very cool things happening there, and of course Juan for your contributions to the discussion as well. It's been really good, and as Ethereum got mentioned, and it is a great library for .NET developers, and likewise Nevermind on the client side too. So shout out to people's stacks and
Web3j too is fantastic. It's if you want to use Java, go there.
Cool. All right, guys. Well, great to talk with everyone, and we'll see you all soon. Okay, thank you.
Thanks.
Thank you, Gunnar, so much. It was a pleasure.
No worries. Thank you, Thomas.
Hey, Connor.
Hey, John. So the sessions, we wrapped it up a few minutes ago.
Sounds great.
Yeah, it
Did
went
you
really
get to
well.
an action item?
Yeah, we
one of the
did.
things I'm trying to, I'm kind of going through all of them right now and making sure folks are creating activities so that it doesn't become just all education.
Yeah, sure. So I'm in the process right now of typing up the notes from the session. But I mean, what was really great though was that Anise was there as well, and Thomas from Nethermind. And so they were able to provide some really useful background. Firstly, Anise was, pointing out how the actual specification can help drive this work, and we're able to clarify which part of the spec people can use in order to actually kick off this piece of work. So it's really cool in that it's actually pulling the specification work in as well as the code that exists right now. So that's kind of an added bonus of it. The other part as well was, Juan Blanco brought up this whole notion of, well, what about baselining on like a layer 2 solution if someone wanted to, whether they didn't want to use mainnet for
Oh, absolutely.
reasons.
That's a big chunk of breakout number 5, right? Or depending on how you're counting. But yeah, the baseline scaling works, scaling the work step throughputs. That's all going to be about layer 2s. The one that
Cool.
Andreas is running. So that's
Yeah,
good.
because the conclusion we reached anyway was that it should actually be trivial if they're presenting just the standard, Ethereum JSON RPC API for transacting with them, then you can just use it there. But of course, if you're trying to span multiple networks, then it's going to get a bit more complex.
The risk I'm taking here, or that we're all taking, is, well, it's not a big risk. I mean, so we have a lot of dead air. It's not a big deal, but trying to make sure that, like, even after this live session, we, people pop back in, have conversations, that it keeps going, that we're activating people to have discussions throughout, the period. And hopefully, I mean, ideally, if somebody like on the other side of the planet that's waking up, in a few hours, go back to what you guys were discussing and then go, okay, hey, let's work on this. So that'd be good. Did you guys figure out, I mean, do you feel like you've come up with any issues that so far that will that we can turn into GitHub challenges?
Yeah. I mean, well, I mean, I think there's a very clear one. So off the back of this, there was kind of, I think two. So there's various ways we can kind of, break this down in terms of, chopping up the baseline so that you can, maybe, like, there's the simple things, which would be, use a different persistence layer or use a different messaging layer, where these are, there's lots of different solutions to choose from. They're tried and tested, well understood. But I think that the two areas that there's probably that are least clear right now, but are important for, growing the overall baseline ecosystem are, one is the actual client. So if someone doesn't want to use Nethermind, they want to use, say, Besu, what needs to be done? And off the back of this session, it was crystal clear insofar as, we need someone to implement like a JSON RPC API that follows the baseline JSON RPC API, and also by extension Nethermind's one that they kind of adapted for it, and that's how you can plug in Hyperledger Besu. And
that makes sense. By the way, you guys ought to get back together tomorrow when Sam's back. He's got a ton on this.
Okay, nice. So that's Sam Stokes.
Yeah, Sam Stokes. He's on PTO today. He sent his regrets, but he's coming back, and he's got a ton on ways to get multiple clients working baseline.
Okay, awesome. Well, what I'll do is I'll actually point him to these notes as well that have that I'm writing up, because my view was that we can take these and basically create like an issue off the back of the epic for this. So at least if we get his input as well, then that's fantastic. And then
that's great. Maybe put him put a @ for him in the Slack for this channel.
Yeah.
And tell him give him a sense of timestamp, like how far back in time he should go to get your on the live stream, and he can just review what you guys discussed on the live stream.
Yeah, sure. Because I mean, the session went for 90 minutes, so we had like it was a really good session.
Yeah, just tell him how tell him what time frame to look for. Actually, he'll be able to scrub. I mean, it's pretty obvious because nobody like right now people will hear us talking, but it'll be pretty obvious where the cuts will be. It'll be pretty easy to cut this whole thing. So.
Yeah, exactly. But the other thing as well was that and Anise highlighted this was, well, what if someone doesn't actually want to use like a ZK snark? It might be that they want to use something else, and so being able to have some flexibility there on the privacy side, that's going to be another key consideration. So I would think that off the back of this session, it's like those are kind of the two bigger impact areas to focus on, because they're almost like where there's more uncertainty because they're not so well established. Like the other kind of the inter-process communication, like, and how these other bits sort of fit together. You can rewrite that in a different language if you need to, or whatever else. It's just kind of fairly standard work. But you certainly in this with the world right now, you don't have lots of choice with clients, and you don't have lots of choice with different zero knowledge. Well, you do have lots of choice, but it's evolving so quickly, the space with zero knowledge.
Sure, the Aztec guys are coming in on that other session as well at some point during this period. So that's Thomas Walton Pocock and those guys.
I know Tom. So I think that those are probably the two best kind of actions off the back of this session, which we can
it'll be great to see those issues underneath that underneath this particular epic on the roadmap, and and boy, the brass ring is for all of these sessions, and presumably this isn't the last we're going to have activity in this channel, right? There's more to come. We didn't just provide a 30-hour channel for nothing.
Right. No. I mean, with this breakout though, the intent would kind of book this 2-hour slot for it. But that's kind of I guess we've covered off what we set out to achieve.
Well, hopefully the people will come back in, and maybe more. What would be great is to see lots of conversations over the period of the next 2 days, right? That's why it's 2 days, not 1 day. So, hopefully other people will get inspired by this. I mean, that's really the goal of all of these, is to inspire people to actually produce work, right? In the repo.
Yeah, no, exactly. And I think, I mean, what I was hoping that off the back of this, we can then, if we can have these issues, and then if maybe we could get some funding from the Gitcoin, for the hackathon to actually support as well.
That's right. Well, we'll be selecting. I can't afford to. We're funding about 8 max issues. Anybody can fund a Gitcoin hackathon issue, as you know. Bounty within that hackathon that we've set up. So anybody can come in there and put more bounties on issues, but we're funding at least 8 or up to 8.
Yeah.
So okay. I'll be looking at the end of Friday at we'll get together everybody and say, all right, what are the issues that are worthy of bounty? And hopefully these sessions will generate those.
Yeah, absolutely.
Cool, man. Awesome. Is this being good? How is this working for you, Connor? Is this how is this going for your company? And what's the brass ring for you guys?
So I think at this point in time, like, we don't have anyone using Baseline, but I think that the opportunity that Baseline signifies is significant.
Oh man, I had a call with a company yesterday. They've got 5 or 6 of the major brands, and they're like, we think we could do what they're doing with Coca-Cola. We can do the same thing.
Yeah,
And
yeah.
these are for like food brands and stuff. And I'm like, yeah, you can. And it was just a light bulb for me. I'm like, oh yeah, this is kicking, right? Because it's not like people are wondering, oh, let me get an education about blockchain. This is like, oh, I have a consistency problem here and here. I need to fix it.
Yeah.
Cool.
Absolutely, yeah. So I mean, yeah, I mean, there's certainly some use cases I've got in mind, but it's more just, it's that whole thing of connecting with the, tracking down the people. What I do want to start doing is putting some content out there around baseline as well, because that's kind of an area that's well, I'm focusing a bit more on content now as well than I have historically. So yeah, it'd be good.
Okay, well, keep an eye out, and let me know what those issues are. Like when you get them logged in, or if you can just talk to Sam and try to inspire some more conversation, more work, more definition, more specification. Ultimately, that's what we've got to generate is more for the specs and more for the repo. We want to get a lot more people contributing and able to contribute. That's really what I'm hoping is that this whole session is going to be about, is enabling more people to contribute more.
Yeah, absolutely. Cool.
Sweet,
all right,
man.
John.
Talk to you soon. Hey, Connor, you're sharing screen just in case you didn't know.
Yeah, I thought I'd leave this open just in case anyone drops in.
Oh, brilliant. I just in case you were, that could have been embarrassing if you were surfing over the email or something.
Yeah, because I put the thing about the summary notes and yeah.
Oh, great idea.
Guys, I'm here. Well, I'll just in case you didn't notice. And hi. And I was talking to Thomas in a chat, so I left this on.
We were just talking about like what kind of like what kind of issues, like codable issues we could generate out of all of this. I think it might be worthy of some time tomorrow when Sam Stokes is back to jump into this room again with some folks that are really, keen. And because he's got some really good ideas about this stuff too.
From kind of an ICE perspective, having a baseline API from the .NET, well, Java and .NET side, when things are settling, are settled, it will be great. I think if they can be hooking into some examples as well, that would be ideal. But yeah, just keeping the.
What do you think? What would you build from an Ethereum perspective?
Well, in it, for the baseline API, it will be the from the smart contract integration, if that becomes a standard, to that seal RPC. So that will be just the most simplistic and an API layer. From an example point of view, ideally, I think we should have the reference examples from Java and .NET in a similar way that we got the JavaScript one. What do you think, Connor? If you haven't left.
No, I'm here still. I mean, I'd definitely like to have that. It's more about just getting the work done. Because I don't have anyone on. I don't have the capacity on my team at the moment to put someone on it. I would love to get someone there to just get it running on top of Besu with web.
You just said the magic words, man. That's your bounty.
Yeah.
Right. That's exactly what I've been looking for. That's what you just did. What I was hoping the summit would do. I wish that we could do this. We don't have resource. Yeah, let's get a bounty up on it. Yeah, there's hundreds and hundreds of people out there that want to do work on this stuff. I did some straw polling. There's a lot of engineers in here. There's a lot of engineers and architects. We actively discouraged everybody else. So.
So I'm creating the first issue, and this is where, like, with the session just now, we kind of figured out what the phases would look like. Because the first part is literally just get it working with Hyperledger Besu, and then there's another piece which is the providing flexibility on the underlying circuit that it uses, but that doesn't have to be done obviously as a prerequisite. And then the other part is basically rewrite what is the JavaScript stack on it for the JVM and .NET. So those are kind of those additional tasks there.
So that's going to improve deployability. What's it going to do for Ethereum? I mean, like where's the brass ring for you?
Sorry, what's the question again?
Well, I'm always trying to find ways for participants in the community to achieve their goals through the community working with the community, right? So trying to what's the brass ring for you? I mean, like what would you like to see result, and how would that be good for Ethereum?
Like I'm part of the standards and I'm looking at everything. So to me, it's as an output, it's having services. If we know that something's going to be stable, then when people are going to come to me for support from the open source, they can say, we can agree that this is something solid, and to me that will be the, that can mainly guide them. That's why I'm asking so many questions.
Right.
You're
working a lot with Microsoft, as I remember, right?
But I used to, but obviously .NET is heavily used by all the Microsoft users. Yeah. So mainly in the same way as people will integrate with Web3j, well, for the Java side, which is 70%, 30% will use .NET. Yeah. So
30% use .NET now?
Well, I don't know, just random
Roughly,
number.
yeah, okay. So what? All right. So I'm trying to think. So if I have a .NET built ERP type application or some other kind of system of record, and it's in .NET, then Ethereum comes into play.
Yeah, it's the same as we did with SAP integration, like we did when I was in Consensus, which is mainly SAP to SAP with a smart contract in the middle. So if you remove the smart contract in the middle, and then you might say like, okay, I want to submit some, part of the purchasing process and so on, and use baseline in the middle, and obviously have some verification of the proof customer submitted. Maybe you might want to create those BAPI interfaces in SAP that provides the information of the proofs or whatever. So those are the areas, the simple areas. And later on, like we discussed, eventually things will move into the mainnet, tokens will move to the mainnet, and then you will want to have a full circle here, as you may.
Parochially, the mainnet or the baseline structure doesn't have a lot of smart contracts, right? I mean, or tokens. It's just 3 of them, right? And they're always the same. They're, well, as we mature them, they'll change, but we're talking about the org registry, the shield contract, and the verifier.
Yeah.
Everything else is in either containers of code that have no bearing. I mean, there aren't blockchain at all, right? They're just code, .NET code or Java code, right? And all you're doing is signing those and saying, yep, the same code here was executed over there. And I think that's an interesting place to think about, right? Where if I've got a container that has some business logic off chain, right? But I want to baseline that container and the data, right? So I don't want to just baseline that purchase order. I want to baseline the business logic that I'm sending you along with the purchase order, right? And that can say, I'm going to Docker that up, send it to you. If I'm not on a .NET system and you're on a .NET system, how, to baseline it, they're going to have to be signed the same, and they're in different execution environments, which is why containers are awesome now. So I'm wondering if that isn't actually an important thing to be looking at with baselining is, do we want to say, hey, you shall use a container system that is, consistent with others, right? Like you're using VMware and I'm using Docker and somebody else is using something else in Kubernetes. I'm not going to get the right signature back, which means I'm not the proof's going to fail.
Yeah. But that's but then you start moving to serverless and start trying to do something with the Microsoft guys with functions or cryptlets used to be.
Cryptlets or Lambda functions, right?
Or where Google has Google functions as well.
That's kind of an interesting idea, right? So you just say, okay, if I have some business logic that goes along with some work step, like here's my master service agreement, and here are the conditionals and the loops and stuff that that involve that particular piece of logic, and I want all subsequent work steps to follow the rules of that container, and I don't want those rules on a blockchain, and I don't want to write them into a bunch of zero knowledge circuit math.
Mm-hmm.
Then you need, we were calling this way back, we were calling this, I need to send you a code book, right? That is the same, almost, I remember I was watching an old Apollo, on the Apollo missions, and how, computers in those capsules, or in those spacecraft in the 60s and 70s, how they operated, right? They were just, effectively code books, go call line 62. All right, now go call, and then line 62 will call line 45, and, and that's how they work. And so you kind of want that. We're all calling line 62, and we all know that line 62 is the same line.
Mm-hmm.
And you sort of want that to be either containerized, or, as you say, maybe like a Lambda type function, where we can all verify. What bottom line is, everybody needs to know that everybody else executed the same logic the same way and got the same result.
Yeah. That's kind of what I was doing with the NetApps a while ago, which
Right.
was the registry of components that were published to IPFS, and
but then I'm breaking compartmentalization again, which is always run back into that problem.
Oh yeah, but register in ENS.
They're what? Sorry.
So mainly this is the prototype. And the idea, well, you can look at it. I can show you. It's mainly I have an ENS registry where I have it's something called NetApps. You can look at NetApps.f, and then each one of them it's got .NET as well. It's part of the hierarchy, and then as you go down, you can see different assemblies or components, and all of those are linked to IPFS. And then you can download the components, and then obviously those could be, well, the idea is that those will be verified by multiple parties, the same as you have jars, or you have well, they are a jar or a DLL, etc., and that can define your execution layer. So I'll give you a demo if I can share my screen.
Hey, Juan Blanco, I've got Andreas in my head, because somewhere on the 500 screens that I have up, I've got the audio playing from. So I'm running all 8 streams.
Oh, right. Okay.
So right now, Andreas is talking in my head. I'm like, oh, Andreas is in our channel. No, he's in some other channel, and I can't figure out which one it is. So I'll have to go look for him. But
yeah, I'll give you a demo, because it was kind of the same as we discussed a while ago about rules engines, and the work that Aaron was doing about, because those are also part of ENS. So if you links those with the company from book as well, that will be interesting.
Oh, there it is. I found it. Whew, that was, I could hardly concentrate at 1 o'clock. I was sitting there listening to, can you still hear me?
Yeah.
Yeah, I was, oops.
Actually, I'm gonna jump into the
ZK
phone book.
In the phone book?
Yeah.
Right on. Yeah, no, I think that'd be great. I'm excited to see you there.
Right, okay.
It's good to see you.
Right. Well, speak later.
Bye.
Right. Bye.
All right, we've got a one of these issues has been created.
Oh, cool. Thanks, Connor. Looking forward. Yeah, we'll do it. We'll do a triage at the end of this and tomorrow, and make sure that we bottle up all the juicy issues, and we'll make some decisions about. I got to figure out some kind of regime for selection, so we'll figure that out too.
Yeah.
Okie dokie.
Okay. Cool.
How you feeling good about this so far? Is this useful?
Yeah. Well, I guess I was surprised that we managed to get through it all quickly and just get to a great result. And I think the reason we were just lucky that we had Tomas from Nethermind there and Ace as well, because me and Kyle, obviously we were running the session, but
I'm telling you, man, if you can pull people back together tomorrow and do round 2 with Sam in the room, you'll benefit.
Yeah. Okay. Cool. I'll drop him a mail and we'll see if we can get something sorted.
Right on. Yeah, cool. And drop some stuff in Slack, letting people know kind of where you got to, and that they can come in and review and maybe add to it. Right.
Okay. Cool. So in just the baseline summit session, or
in general chat. In general channel cool. Is fine. Just say, hey, because I know we have several people from India and that's a growing group coming. There's several universities that are popping in and out. Carnegie Mellon's here, so just make sure that they know to go and take a look.
Yeah, nice. Okay, awesome.
All right, man. Talk to you soon.
See ya. Hey, Xavier.
Hey, Connor.
How have you found the sessions so far here?
Good. Yesterday was quite technical. I unplugged at some point during the zero knowledge proof circuits, but yeah, it's been very interesting.
Yeah, cool. Yeah. So were you here for much of the client session here yesterday?
No, mostly I was only in the first breakout in the core the first and the core interfaces.
Yeah. Okay, cool. Because maybe I can take you through some of the stuff we were talking about yesterday.
Okay.
If that suits. Oh, hey Sam, I see you're here as well now.
Hey Connor, how are you?
Yeah, good. How you doing?
Doing good.
Cool. Yeah, if you've got time now, that'd be awesome to have a chat, because really today, we had a really productive session yesterday, but there was some follow-on questions, and I was having a chat with John later on, and he mentioned basically that it would be good to kind of sync up.
Sure. Yeah, happy to discuss.
Cool. So for your benefit and also Xavier's as well, I'll share my screen, and then we can kind of could go from the perspective of what we actually, what was being discussed yesterday. Right, so let's just make sure. There we go. Okay, so the original sort of goal and intent behind this session was to talk about, the actual areas for where we could really broaden the support for baseline beyond as is currently the case with Nethermind plus JavaScript, and actually open it up to work with Hyperledger Besu and potentially on the JVM stack as well for some of the core pieces. Because I think if you kind of, if you cover off those areas, you've covered off a lot of enterprise. And Ace was also, she pitched in just about the specification and how, the specification is obviously going to be a really great reference point for people to work from when it comes to doing, other implementations and support there. And so we kind of, we got down sort of through the, let me go to the notes here from the session yesterday. But I mean, I think one of the takeaways anyway was that you've got this baseline RPC specification that's emerging, and any Ethereum compatible client that exposes this RPC, well, I guess baseline RPC, it shouldn't be too much work then to actually integrate it with baseline. but what Anis was saying too is that there is that question mark around the actual circuits that are supported, and whether potentially we actually want to look outside the realm of, say, just ZK snarks or other sort of privacy protocols. And I guess this was an area where we're thinking, okay, is there kind of scope at this point for creating a actual issue to to discuss really the steps that would be required to actually plug into some other privacy technology. I'd imagine, I guess, say a zero knowledge technology, but I got the impression you potentially had some thoughts around this, or it's an area that you kind of scratched the surface on.
Yeah. So the past couple of weeks, I've been working, been talking to some members of the Hyperledger Besu team that work at Consensus, and trying to get Baseline working with a Besu client.
Yeah.
And the approach that we're taking is, I've been working on what I've called a Baseline relay server.
Right.
So it would basically, it would act as the JSON RPC server, and it would sit in front of the client so that it would act as your Web3 provider.
Right.
And it contains the logic for all the baseline JSON RPC methods, and then any other methods that are hit, such as like any of the traditional Ethereum JSON RPC methods that it receives. It's just going to blindly forward to the client that's sitting behind it.
Okay. So there's already. Did anyone from the Besu team actually join the summit?
I haven't seen. I kind of expected them to be around, but I haven't.
Yeah, we didn't have anyone yesterday talking about it, so it's it's good. I mean, certainly good to know. Because I did have some discussions previously with David Metchler. Was he involved on those discussions on that side, or was it other members of the Besu team?
Yeah, it was David and Tim Bako are the two that I've talked to from the Besu.
Okay. Cool. So I think it'd be good to get their kind of input on that, because of course, if stuff's already happening here, then it makes less sense to kind of do some additional pieces on it. And so sorry, what were they calling that component? Like just baseline relay?
Yeah. Baseline relay is it's just a microservice or Docker container that sits in front of the client. So it could it's designed to work with, it could sit in front of a Besu client, or you could have Infura behind it, or the idea would be any Web3 provider could sit behind it, and it would add the baseline functionality to it.
Okay, and would that relay actually contain the Merkle tree within it as well?
Yes. Yeah, it provides the logic and the code responsible for maintaining the off-chain Merkle trees.
Okay.
So the idea is it has a separate, the way I've done it, I guess it could work other ways, but I've designed it to have a MongoDB container that runs alongside of it, and that's where the Merkle trees actually get stored. And it contains all that data, and all the updates happen within that database.
Okay, cool. That's useful to know. We'll get them then to provide some context for the actual issue that's been created then. The other thing to touch on would be the where are we? Was this notion of I suppose the support of other circuits. I know that there was like a separate session on that specifically in terms of the circuit improvements. I wasn't able to make that session, and of course there's still discussions happening there at the moment. But is there currently like a path sort of planned out in terms of providing support for potentially other types of circuits, or is it more just about right now more focused on just incrementing what's already there? I know John had mentioned Aztec as well as one that is being looked at potentially by the Aztec team, I believe.
Yeah, I don't know so much about other zero knowledge technologies outside of I guess Socrates, which is the one that's in use right now.
Yeah.
But I mean, the baseline RPC interface is pretty agnostic in terms of what. I don't think it really cares what ZK technology is sitting behind it. As long as the verifier contract on chain matches the interface that it's expecting to interact with, it should work. Like the actual verification process and generation of proofs, as long as you have the same inputs and output types, I guess the baseline relay service and the Ethereum client that you're using really shouldn't care about what zero knowledge technology you're using.
Yeah. And at this point in time, has anyone made any noises, or if anyone else on the call has got any views here, if there are specific other ones that there's interest in?
I don't know if it has been discussed before, but you mentioned, Connor, about two interfaces that are currently in core. So there are the IZK-SNARK circuit provider and IZK-SNARK compilation artifacts. And my question to Sam is, or to anybody else, sorry, Sam, not, but I think you may know maybe a bit more, you're closer to this. Are there any plan to kind of abstract those to the point that Connor was making earlier, to be a bit more zero knowledge protocol agnostic in core itself? So those two interfaces, is anybody currently looking at them and asking, can we abstract those even further?
Yeah, I'm not sure. I think they're abstracted a bit already, but it's definitely possible that it needs a further layer. I can show you the let's see. Can I share my screen real quick?
Yeah, sure.
Okay. There were some updates to the baseline core contracts package recently, and part of that was defining this interface I'm talking about. So this is within contracts, and there's a subfolder called privacy. So the verifier is the one, like right now, Socrates, the way it works is it produces this verifier contract for you. I'm not sure how other zero knowledge technologies work, but either they would need to create this themselves, or I guess you could manually go through and create a verifier contract that's verifying the circuit that you've created. But yeah, essentially you just need to have a verifier contract on chain that matches this interface. This is the one that the shield contract calls. So I don't know about other zero knowledge technologies, if they have, the same data format here in terms of proof and public inputs. This is the way Socrates works. You feed the verify function or method these inputs, and it's just going to return a true or false and tell you if that what you input, if the proof was verified, you get a true back. If not, you get a false, and that's pretty much all the feedback you get in terms of on-chain.
Okay, thank you. I think, well, I'm far from being the most appropriate person to discuss ZK circuit, but based on the conversations that I've heard, there may be a need for other parameters to be included for specific zero knowledge protocols, but the base it remains the same because they are all based on like private input, public input, etc., etc. So yeah, I can see that it is abstracted enough to cater for ZK-SNARK and maybe other protocols, but I don't know that for few other protocols that were mentioned that will be sufficient. So I guess from a specification point of view, and not, well, it's not even specification, from a standard point of view. So I'm really referring to the API and data model baseline standard, Oasis standard. Do you think that the current state would be and will stay that we have to use the ZK snark? We have to use ZK snark, basically, and not other technologies or ZK protocols? In core, for example.
Yeah, I think it can certainly be modified to work with other ones. I mean, currently I've only worked with Socrates thus far, so I don't think I know enough to tell you what would need to be changed to accommodate for other types of zero knowledge technology.
Okay, thank you.
But potentially one change, if that interface doesn't work for other zero knowledge technologies, maybe we could, as part of baseline, we couldn't just use the verifier contract that Socrates spits out, but maybe we have an intermediary step that I guess changes the verifier contract, modifies it a bit to match a different interface that works for several different technologies.
Yes, that makes sense. One approach could also be, from a standard point of view, is that the requirement is that a privacy interface must be implemented, but we don't impose any zero knowledge protocol, but we do say, if you are using ZK snarks, you have to use iZK snark circuit provider and iZK snark compilation artifacts, etc., etc. So if we say that there are a list of zero knowledge protocols supported, and those interfaces are must-have for any client that want to go and use those supported protocol, but for any other protocol, they will have to basically have their do their interfaces from scratch and do everything, as you said, write their own verifier contracts and everything. Would that be something that sounds reasonable?
Yeah, it does certainly sound doable. I guess with the concept of the baseline relay service we were discussing earlier, it would be nice, if there was a common on-chain function it was calling, and that it would work with all these different technologies instead of having to, I guess have different code in there, and it's having to call different methods depending on what zero knowledge verifier type you're using.
Yep. Yeah, that was it. That was my question, Kono. Thank you.
Awesome. So, I mean, from the takeaway there is, I guess it might be that it would work with a different protocol, but we'd need to kind of, well, I guess choose one and see, right? And if we can get there, then yeah, we'll understand more if the interfaces need to be adapted or not. Out of interest, Denise, in terms of the specification, where you have these interfaces defined in Solidity code, do you know at this point in time if this spec is going to talk to actual Solidity code, or if it's more that it's going to talk just to the interfaces in more abstract terms?
Definitely, we will talk in more abstract terms. So any example of code from core, so V01 that has been released in August, will be for non-normative. Those will be non-normative examples. Yeah. So we are really focusing right now on the iRegistry, iMessaging service, iVault, iBaseline RPC, iBlockchain service, the iPersistent service, and the ZK snark-related interfaces that we mentioned. So those are the core interfaces that apparently will must be implemented. And so the goal is to ensure that we have in the specification all the right functions. If you remember yesterday, I mentioned the deploy function, and Thomas on the call said, "Oh, actually, we have already evolved faster." So we need to ensure alignment. And we need to work very closely on the team actually doing the development and understanding why some functions have been deprecated, replaced, or those type of things. And what are the caveats for using those as well, if they exist? Because one gap that we may have in the documentation right now is that understanding the why. So we know, we can see the code, we understand what everything does. We just need sometimes to have a better understanding on our side on why do we use that function rather than that function, because before we were doing this and that, so we understand the rationale. So yeah.
I'm going to jot down some notes as we go as well.
Oh, sorry, maybe I speak too fast. Sorry.
Yeah.
So
is it correct to say that the examples of code would be non-normative for the standards?
Yes. Yes.
Yeah. Cool. So make sure I get the right terminology there.
So we are trying. It's a bit more straightforward for the API, of course, because it's so tied to the code that is being produced. But on the core specification, we really try to abstract. Even the iBlockchain service, if we think about it, this will not be a must-have. The way we may approach it is to say, if you use a DLT that is a blockchain, then you must implement this. But it should not be like a must-have requirement, because the way we have approached the baseline protocol, it should be DLT agnostic. If you think about it, you don't need a blockchain to do baselining. So this is where we are going with the core specification. As a result of this, we need to align the API specification in the same mindset. So because we need to be consistent in what we are saying. So as we say that baseline is only exclusively on blockchain. Therefore, we will say that client must implement the iBlockchain service regardless, or we say should if we use blockchain. So those are the type of little details that we think about on the specification side and that we are discussing.
Yeah. And so actually on that, so at the moment then, have you decided whether or not the kind of blockchain piece is going to be a mandatory piece or not?
The current conversation is no. It's not a mandatory piece. No.
Well, Anais, what would be an alternative to using the blockchain?
Well, there are others. So I remember Andreas mentioned a couple of other DLT, distributed ledger technologies, which are not blockchain. And he was the one knowledgeable enough to be able to challenge this point. So I won't go there. So I would update to this. I won't be able to give you an example, but this is why we had the conversation. And yeah.
Okay, no worries. I was just curious.
But I'm sure it's easy to find, to be honest. I just don't remember. So.
Yeah, it's an interesting idea. So it would be another blockchain or just a non-blockchain?
A non-blockchain, not another blockchain. So we are not talking the mainnet Ethereum block, no, like a non-blockchain distributed ledger technology.
Oh, okay. Like a DHT or something like that. It's a distributed hash table or something like that. Or anything else. I mean, because a replicated database can be, that's interesting. Like a worldwide Mongo cluster.
Yes, exactly. But then again, this is when we'll get into the detail in actually establishing the level of requirement. So everybody on the call, I'm sure, no, but we are looking at must, should, may not, should not, must not, keyword. So what we are asking here is, should we say that a baseline implementation, a client must implement iBlockchain service or should implement iBlockchain service? That's the question. And one question that we can ask is, can we even abstract the iBlockchain service?
Yeah.
And if we do, then it does not matter, to be honest, this conversation, because we'll have an interface which is abstracted enough that it can be used by for any kind of DLT.
Right.
Yeah.
So like the word blockchain maybe should be removed from that interface, or at least considered as what is its job, what's its role in the overall context of baseline, and like, is it a iDurability service instead of an iBlockchain service, or a iPublic consensus service? Or maybe the word public is too much, some kind of consensus service. I don't know. That's interesting.
Yeah, exactly.
That's not to take out the word blockchain and then figure out what it actually, what job it's performing there in the context of baseline.
Yes, exactly.
Yes, it's a really interesting, I guess, the thought point in terms of what direction it goes. Yeah, as you could almost look for reference at what does DAML plug into at the moment, and say, you know, at the very least, all of those things.
Actually, do we have some, I don't know, Sam or Brian, some codes that show what functions are even in this interface?
Yeah, Sam.
Sam, what do?
Because are you referring to the iBlockchain RPC interface?
Yes.
Yep.
Or the iBlockchain. Or is it iBlockchain RPC or iBlockchain service? The name of the interface. I thought it was iBlockchain service. But I'm sure we are talking about the same thing. So it's just a detail. Please disregard.
Okay. Give me just a minute. I'll pull something up here.
I was looking at, I guess, speaking of changing names for interfaces, excuse me, I'm having a second breakfast here. Looking at the ZKP interface, and like, I was working through some scenarios where I was like, do I even need Socrates or Snark, ZK Snark type service? And does that mean I can't baseline? You know?
To your point, Brian, if we say that one core component of the protocol is a privacy component, we definitely need to have a privacy interface. It doesn't matter what zero knowledge protocol. And actually, yeah, zero knowledge protocol is required. I was, going sideways and say, oh, but do we even need zero knowledge protocol? Can it be another type of cryptographic protocol? But let's disregard. So I do think that we need a privacy interface and we need a zero knowledge protocol. Now, I strongly think that we should not say that we need ZK Snark, because why? I don't see any justification for this, to be honest.
Yeah, I hear you. I often find, I guess, my habit, which is, I don't know, good or bad, is to reduce, just to distill ideas and things down to their essence. But it's like, at some point, we're going to end up just describing in our standards like the facets of modern computing. It's right. It's like, oh, does it have to be blockchain? Well, no, I guess it could be anything. I mean, we basically are just this. We just have the most generic interfaces that could be applied to any technology anywhere, and then we've basically, boiled away everything that's interesting. So we don't necessarily want to go too far.
Oh no, I definitely agree on this.
But it's part of exploring, I think, what actually this technology is, but and its value. Anyway, I just wanted to throw that out there.
Sam, you are sharing your screen?
Oh, yeah. I just added something to the notes section for this this breakout room. If I can show it on my screen. These are the JSON RPC methods that I included in the baseline relay service I've been working on. So
Yep.
most of these are the same, but a few variations from, I guess, what's in the repo right now and what Nethermind had done in their first iteration. Namely, we got rid of the baseline deploy method because it was essentially just re-implementing some of the ETH_send transaction, you know, the traditional way of deploying contracts on chain. And then, you know, a few other variations. I haven't added the full list of parameters and everything, but maybe this is a good starting point for everybody to see what's been going on. And I think the iBaseline RPC interface pretty much just has a method for each one of these methods, kind of a one-to-one mapping that would call these. So not sure if that's what you all were looking for, if that's helpful.
Yes, that's helpful. But you add before that the iBlockchain service, I believe.
Oh, the iBlockchain service. Let's see. I guess that would be a part of API. You specify that is one of your providers. Is that what you're referring to?
Somebody was sharing a screen. It may
Oh,
not
that
have
would be,
been you.
I've just pasted it into the document as well, a screen capture.
Oh, okay, great, thank you.
Scroll up.
As a feedback comment on the baseline RPC interfaces, most of the methods are related to the Merkle tree. So then those be categorized as such, and mainly because like get leave and wherever, you know, is very specific to that specific functionality. I don't know if that will make sense. Is later on other more real specific functionality to baseline, because this is just the helper for the smart contract, kind of retrieving the tree. Yeah, so something like baseline Merkle or something like that. That kind of categorize this into what it is, because we have as well the deploy as well. I know I've seen it somewhere just before. Yeah, and also you I don't know if this covered this, but you may have different seals that are being deployed as well. I don't know. I really am just looking at the methods at the moment, so I don't know if this it covered a specific scenario.
Oh, where you have multiple shield contracts that you're involved in?
Yeah.
Yeah, most of these methods will take a shield contract address as one of the parameters, so that
Right.
it knows which one you're talking about.
Yeah. Or maybe it will be like space line sealed, get leave, so or something like that. So just to kind of categorize it a bit better.
Okay. But what are the
Yeah.
functionalities? Are there already other things that you are thinking about? One?
Well, at the moment, no, but looking in the future, maybe, you know, the seal contract might be, you know, not be the one of the kind of drivers.
That's
well.
true. Yeah. That's a good point that you are making, and that's a point that was raised before. Is there are other shielding mechanisms. The shield contract must not be must have requirement of the baseline specification or baseline standard. So from that point of view, yeah, I fully aligned with what you say, is that if the iBaseline RPC sole function is to interact with the Merkle tree within the shield contract, but the shield contract itself is not required, how can we say that the iBaseline RPC is a required interface? So yeah, that's a very, I think when the time will come to have this conversation during the standard and specification work group, yeah, so I expect some strong opinions on that, to be honest.
Yeah, and obviously we, in this scenario, we know that it's for the sale as long, yeah, we could say baseline seal, get leave, wherever, and then everybody will understand it. And then if you don't have a sale contract, well, you just don't use it. Yeah.
Yep.
Also, I don't know if this is maybe not it's related, but the Shield contract itself, we might consider a different name. I mean, I like it, but it's not. Its origins were Nightfall, and in Nightfall they have Shield contract, and in that implementation, it literally does shield. It shields the movement of tokens behind the facade of this commitment that's used as a proxy. And in baseline, at least the current implementation, there's no, it's technically using that same mechanics, but it doesn't quite, it's not quite a shield. I mean, I guess on some level it is, but not in the same way that that they're shielding token transfer in Nightfall or Nightlight at this point. I don't know if that's relevant, just a little nuance to throw out there for.
Yeah, it is relevant, because if we are saying that we inherited the Shield contract as a mechanism to hide transaction, like movement of transfer and values, etc., and that we progressed on this, so we inherited from Nightfall, and then we improved on it to accommodate the baseline needs, and now we are saying, but there are other ways to do that. And if we look at some existing EIP or other standards, we may realize that that may not be in the future the recommended approach, right? So are there currently, and it's more a question for everybody, are there any currently good candidates, either in terms of token standard or proposals that you may have seen that are good candidates just to replace the Shield contract or to complement? I don't know. I'm just raising the point here.
I was just going to say, I've got to jump quickly, but if someone's able to just take some notes, because I've got a meeting I need to be on. But it's really cool that this is moving forward, the discussion. We'll be back.
Okay. So, because I'm aware, I'm not to close off the conversation, but Andrea has mentioned that, actually, Andrea and Cal, I think they were having a discussion about how they are either investigating or working on something that make the Shield contract, how can I say, not deprecated, that's definitely not the right word, but not as cornerstone to the whole baseline, framework as it was even a few months ago or a few weeks ago, to be honest.
Oh, interesting.
I don't know, do you have any insight?
Is anybody who does on the call? I was just going to say that the Shield contract, it has like a structural function in terms of like what it does in baseline, but it doesn't provide the shield, right? As like in the context of Nightfall. But I'd be curious to see if like you could, like if you basically, I don't know what I'm going to say. We could think of, again, maybe going back to what we were talking about with the blockchain, like what is the job it's performing? And is it actually shielding or is it doing something else? Is it, I don't know, more of a workflow manager than a shield? Anyway, I'm curious to see what you said, Kyle, and
I think Kyle and Andreas, which would definitely, it will be great to have them on.
Maybe we could see if we can pull them in.
Yeah, that would be great. Particularly Andreas, I think he has a very strong view on how to do it without a Shield contract or something like that.
What was the topic for? Or we're at 11 o'clock. Are we? Is the session wrapped or?
Oh, true. Because this was a 2-hour session, right? Oh, I don't even know.
Who's in charge here?
Hey, I'm Ace. This is Mark.
Hi, Mark.
This is the only session that is live right now that I can tell. At the opening plenary, there's only 3 people in it, even though it does look as though there's some movement now. But this is the only session that's having any live content right now.
Oh, okay. Oh, okay. So we can just keep going. We have Andreas. Andreas, are you here?
Yes, I am.
Oh, okay.
Yes.
Thank you.
What
We
how
have a
can I
question
be
for
of ser-
you. Yes.
Oh,
How can you
okay.
be of service?
Yes.
So we
Shoot.
were discussing that the shield contract is not a must-have requirement as part of the standard, and I was like, what would be the shielding mechanism? Because I remember you mentioned something, but yeah, I couldn't remember, or I'm not knowledgeable enough, to share with the rest of the team. So if we don't use the shield contract, what could be another way to achieve the same function, basically?
Okay, so first of all, it's all the discussions are obviously rooted in the current reference implementation, which is a particular implementation of a possible implementation of different implementation patterns, right? So the shield contract's basic function is to preserve privacy, right?
Right.
Privacy of the participants and right.
Kind of. But how we're using it, I feel like that's what like the ZKP layer is kind of doing.
No, I mean that's yes, but it's the shield contract is there too for the group participants and the anchoring of the proof, and it connects to the Merkle tree contract.
It's an anchoring point, like the verifier contract, right? That's generated, at least in this current implementation, right? That's what's enforcing the correctness on chain of the off-chain computation, and then the shield is kind of the glue that anchors that implementation there to specific other parties that are participating. Like it's tying it to the rest of data elements that are on chain or other data points and other data documents that are in a workflow. So I was like proposing it's more of like a workflow manager.
It is. Yes, it's like, is it the right workflow? Is it the right work step? Is it the right participants? Blah blah blah.
Yeah.
Yeah. I think again from an implementation point of view, is an option. I would say that should live entirely off chain. Because it's just simply not scalable, right? So from a scalability point of view, you wouldn't want that. You would want to have a contract, a governance contract that manages the anchoring and verification of transactions on chain. But that's about it. Right. I mean, if you think about it,
or multiple workflows, is that kind of like one governance contract for all, or for a work group? What would be the scope of that governance, or does it depend?
That can depend, right? If that depends on your operational model, right? Do you have a single operator, or do you have a network of operators that run the same stack?
Yeah.
Right, and so can multiple ones write into that smart contract architecture, or just one, or a set of, right? So that's the I think there is no need to have any on-chain representations of users.
Well, users, like entities.
Participants in a workflow or in a work step.
I see. Interesting.
Right? Because they're unless you have a tokenized asset on chain, why do you need that?
Yeah.
Right. I mean, okay, if
you route,
okay.
that's kind of like, I feel like something that's come up in other discussions, especially yesterday with Karthik and the ZKP. It's like if you're heading at tokenization with this, like invoice factoring and all that, then there's a lot of things you kind of have to do to get your data and everything into the, like I use the term on-ramp of tokenization. But if you're not ultimately tokenizing, then I feel like, yeah, there's a lot up for grabs in terms of what you can do, a lot more flexibility.
So we discussed that yesterday in scaling, and our approach would be, it's like privacy preserving. Yeah, use ZKPs, but use ZKP rollups and keep everything on chain, and the blocks that you would normally write on chain, you keep off chain, and you just anchor that through a content addressable hash. You're done.
Yeah.
Right, and then that points to an off-chain storage, and then you have the data availability problem. But if you're not tokenizing, then who cares, right?
Yeah. Well, so in that roll-up strategy, like, are you? I guess I know conceptually the roll-up, but like, is it almost what is managing the roll-up and what gets rolled?
An operator.
Like, yeah, but I mean, I guess, yeah. So is there a single operator that's sort of moving towards a more centralized or quasi-centralized, like?
Yeah, think of it.
Yeah.
Yeah, think of it as a single node virtual state machine that doesn't require consensus, because the operator can't do anything. The only thing the operator can do in a ZK rollup is censor. That's it.
Okay, so these are rollup nodes that are alongside. Is this like you're like potentially using like the rollup strategies used or talked about in like in the Ethereum context of like for scaling? Okay.
Yeah, so you can have different rollup strategies, right? But if you want to preserve privacy, which I guess people want to, your primary purpose is going to be to use ZK rollups, because that preserves privacy. Nothing is because you will have, I mean, think of it this way, it is highly unlikely. So from an operational point of view, that you'll have a baseline stack for each pair, for each bilateral pair of entities, right? Because it's just not capital efficient. I mean, you could, but that's, it's from a scalability, from a cost point of view, it's just doesn't make sense. So you'll have an operator that has like 1,000 customers, right? And they use baseline, and they pump their transactions through that, and by rolling them up, you get to transaction costs that are less than a penny, significantly less than a penny, like a fraction of that, right? Because you're anchoring 10,000. If you're doing like a ZK rollup and you're not anchoring it on chain, you can do 10,000, 20,000 transactions.
What are
in a second?
Yes, and in that sense, though, you're trading off transaction speed for what, though? Because like in how baseline is at least structured in current implementations, or maybe even going back as Radish, is like you have multiple parties who are watching a particular commitment and listening to events from a particular smart contract so that they can stay in sync. So is the trade-off efficiency for what was the term? Consistency or time to consistency?
No, not necessarily.
How do you get the? It's kind of like a side effect in terms of how it's designed, right? Because it's not a direct data exchange between parties. It's sort of like, oh, I listen for events on chain for data that I am already paying attention to in my local system. So how do you know if that's like, do you still get the same events and log?
Let me give you an example. Let me give you a very simple example that probably everybody is familiar with, and make that really simple. That's LinkedIn messaging. Okay, so I sent you a message, hi, right? So what's our agreement? Our agreement is that the messages we're sending back and forth to each other are the truth, right? So if I say hi, you can be assured that I actually said hi, right? How do you know? LinkedIn could have changed what I said.
Yeah.
Right. So, but if I were to baseline that message, then you know exactly that I said hi. Right. So, and then you write, okay, I acknowledge that by writing back, I have acknowledged that state, and I update the state with my subsequent message. Right. So that's the back and forth that's happening, and LinkedIn can't do anything about it, except shutting down the messaging. So the only thing that I'm doing is I'm creating anchor points that I put on chain at one point, so we have a you know, there's something that we can point to and say, hey, you know, it's like, we know that in this block our message was in there, so we can, you know, LinkedIn, give me the data and proof because someone is suing me or something like that, right? So the point is I can scale that, right? LinkedIn scales, right? So it's messaging, right?
Yeah, yeah. Well, it's just sort of the mechanics of like how you actually. So let's say in that scenario, like you sent hi to me, and I need to verify that you actually sent hi to me. So I have to go and take the content that you've given me, hi, and the other metadata along with it, and run that through our agreed upon hashing or zero knowledge scheme, right?
No, actually, I'm attaching a proof that I said hi.
Okay, so the proof comes with the message.
Right. That's the key thing, right? So I don't need to check anything. I just check the proof, and if the proof works out, then I know that, oh yeah, this is it said hi, right?
And you know there's no intermediary messing with that proof or generating a second proof because I can verify the identity out of band. Like, where's the?
Yeah. So you have
just providing all.
So right now, identities are verified out of band, right? Always out of band, right? So if you're trading with someone in a DEX, right? It's like you know, especially if you're an FA, you check who you're trading with often. So it's like, yeah, this identity that's what the global phone book is for, right? You want to do that. You verify identities out of band.
Okay, yeah, no, I was just understanding from the context of the LinkedIn message, like what information I have to go out of band or verify.
So there's a phone book, right? Your contact list, or, you know, it's like the LinkedIn universe of verified identities, quote unquote. But let's say they LinkedIn were to use a phone book and had a KYC process that assured correctness of identity, which the global phone book here is Track is trying to achieve. So that exists.
So then I guess to dig into the example a little more. So you're sending the content and the commitment proof, right? So then I can verify that locally, but then I can also verify that on chain too, right? That would be up to me how much I wanted to.
Right. So the easiest thing for me would be to
you can generate the proof and then just not submit it to the rollup, your side of the commitment. And then
I mean yes, you can trade ZKPs off chain, you know, as much as you want. You don't need that, right? It's just you just have a messaging system, and then you're trading back a zero knowledge proofs back and forth.
Fun. You know, everyone needs a hobby.
Right, everybody needs a hobby, right? Exactly. So it's like you don't need anything on chain in principle. If you trust each other and you have you know, you've agreed upon what your VSM does on each side by, you know, having an agreed upon smart contract input that is the general prover service, right? So you're using something like Zinc or Noir or Cairo, right? Pick your favorite generalized ZK language that allows you
those are. Wait, sorry, Zinc. I've never actually heard of Zinc, Noir, and what?
Zinc, ZINK, that's from Matter Labs. Then Cairo, that is from Starkware. And then Noir, which is from Aztec. So they're all, so Noir is sort of like fully anonymous rollups. And then Cairo is rollups, but with Starks.
Oh, Starks.
And Zinc is ZK Snarks with Plonk.
Oh, okay, interesting.
So those are all new. Those are de facto. They can do that because now you have new commitment schemes, and with new commitment schemes, you can have larger number of constraints. With larger number of constraints, you can map more complex programs,
right?
Into circuits, and then generate commitments from that, which are then just translated into bytecode, which is then, so it's literally like the EVM. It's just that the architecture of the virtual state machine is not technically speaking, it's not a von Neumann architecture. It's a polynomial commitment architecture.
Oh, okay, gotcha.
Right. So because you're just verifying constraints, right? You're verifying cryptographic commitments probabilistically. That's what you're technically doing.
Interesting. Okay, I will have to look into those.
Yeah, it's a bit of that's sort of like, it's like math 2.0. It's highly non-trivial. Right. Yeah.
Yeah. Wait. So what were we talking about? Oh, yeah, the need for shield contracts. So I guess no.
Yes. So not that is an implementation choice. You can do it this way, but you don't have to. There are more efficient ways of doing that. Let's put it this way, right? So it's like if you're trying to minimize your on-chain footprint, if you don't want to tokenize, the absolute minimal contract that you need, I can send you the code for that. I have that. Solidity code for that. It's like that's the most minimal. That's the most minimal thing.
How many lines is it?
I can post the link if you want to.
Sure.
It's actually,
yeah.
It's actually on GitHub. Let me it's public. It's within the element implementation of SciTree. Second. Just need to find it. No, wait, that's the wrong one.
So while you're looking at it, does anyone else have any other topics that you want to discuss? I don't really know how to be a host kind of thing in this, or who's running this?
Oh no, it's not EPS lib. Duh.
One of the things I guess something I'm always just still struggling with currently and trying to just wrap my head around, like what and how you represent in your business workflows in a Stark or Snark based circuit, or I guess whatever Zinc and Cairo or Noir have as their abstraction layer that allows you to define logic, write a program if they use a native language or some DSL or something.
Yeah, I can hold on. Let me ping you the let me ping you something else.
It's like, often you're struggling with a mix of data and date and rules around when that can change in context. And it's like, I guess that's really what it comes, how much context of the business process do you push into these control structures? And because of how they have to run, you know, and that they need a lot of, they need almost like a black box. I think, well, any of these cryptographic proofs are largely black boxes to most everybody other than the people who wrote them, just because the level of understanding is so high, I think. So I think it's appropriate to treat them as sort of black boxes, but it requires so much external context that, and then unique ways of rephrasing like that, the rules and things that like you almost end up duplicating. I don't see, well, I guess I haven't written any in production, but I would imagine that you would.
I mean, this is like cutting edge stuff, right?
Yeah.
I mean, all of this stuff, like, you know, was like since July of last year, right? I mean, literally, it's like a year over a year. There were some real big cryptographic breakthroughs that like the Aztec guys did, and also the Alien and his bunch over at Starkware. So that's like just in the last year, and that is now just coming into production.
Mm-hmm.
Right, but that's clearly the way forward, right? Because you can with these general prover services, right? You can now just write code as I put the link in there to like the Zinc framework. You can just write code as you normally would, right? It's like a JavaScript type, Rust type language, right? And then it works very similarly. And then, you know, you have a compiler, you know, and the compiler does all the magic, you know, converting it into circuits, doing commitments, and then you know, converting those commitments into bytecode.
Just sharing my screen here so we can maybe look at the code. So it's in
it's the code is in contracts.
Okay.
And you can run those. So there's that's a. So this is simply a contract that allows you to anchor a registry entry. Right. So the committer, the anchor hash, and at what block height.
Okay.
It's there. You can, if you run truffle, you know, you can just take the code as is and use you know, you can deploy it. You can run it locally on Ganache, and then you know, run that code. There's an explainer. You can just follow that, and you'll be able to run it. It's just a simple contract for then staking. And if you're trying to spam the contract, so you have to be an operator for the contract to be able to write to it. And if you write to it more than once a block, then you're getting your ass kicked. You're getting your stake slashed.
And that's that function down here, right? Slash operator. So you burn it burns it for you. Yeah. Okay, so then the concept of a stake as it relates to baseline, this would be the commitment that you generate off chain.
Yeah. So this is then just an anchor hash. The anchor hash could be then just a URI that points back to your data storage.
Yeah. Okay. So then, interesting. Okay.
Right. So I mean, you could even go so far as saying the only on-chain contract for all baseline operators in the entire world could be this contract.
Right. Yes. This is very generic. It's like, yeah.
Yeah, this is really generic. If you want to anchor a hash, this is like, and there's it's a very straightforward, simple. You need to register, and if you want to register, you need to stake. and then you can only submit. There's only one transaction a block allowed for each operator.
What's the amount used for?
Right now, it's hard coded to be 32 ETH.
In that you have to stake that amount of ETH to be an operator?
Yep.
Interesting.
So and again, that could be, do a governance contract, and then you can update that value, right? It's set in the governance contract, right? It's like big deal, right? So you can have a function that sets that variable.
Sure, yeah, and have some other library pull in to balance it appropriately given, I don't know, whatever.
Yeah, and you make it can only be called from the addresses and the governance contract. So you can expand that functionality, but this is sort of like the most minimalistic anchoring contract that provides enough security so I ran this through through MythX, and it's all secure. I mean, I haven't found anything in there. Right? There's reentrancy protection, blah blah blah. Not the reentrancy guard from it's early for me right now.
That's pretty smart, right? So it's like even if you accidentally do this, you're getting slashed.
Yep. You gotta be on your best
behavior in a game here, really.
Right. So you better
replay condition where yeah, I guess because it's by hash. Yeah, interesting. Okay. Interesting. Yeah, this is really cool. Thanks for sharing.
Yeah, no worries. I mean, it's open source, so it's again, that's I've found this is sort of like a very brutal but most minimalistic staked an anchoring contract that allows you to provide minimal or strong security guarantees without being
how
fancy.
this might work in the baseline context, like if the operators are like, do we deploy one per work group, and then the operators, everybody who's participating,
you could just do one for all baseline operators in the entire world.
Yeah.
In principle, right? Because you're just if you don't want to tokenize, that's all you need. Right? You just need to have pointers that point back to data repositories
but like if you
for the off-chain data.
I wonder though if you wanted to, so if I wanted to say use this, this becomes, I'm just thinking kind of out loud here, so it becomes my quote, what replaces the shield contract, and I have everybody in my work group stake, but I still want to use a verifier contract in conjunction with this based on sort of business logic. Then I could probably put that in when you're registering your anchor hash, just a call out to that contract to verify that, because the hash is the commitment.
Right. If you yeah,
before I actually maybe if you
want to verify if you want to verify that, but again, think of this as a if you want to write an anchor hash, right? If you would have to say what type of hash is it, right? Is it just a URI hash, or is it a ZK hash? Right?
Oh sure, yeah.
And then you need to know what type of commitment scheme you are, what framework you're using.
Yep.
So if you want to generalize this for like one to rule them all, then you would have to add more fields here. right? If
Right.
you wanted to do that, to make it like, but then again, it's the you know, you want to you know, if I would probably use a different, I would use this contract for I would actually write the smart contract architecture as a so since this is not upgradable, right? And you want to upgrade that, I would actually write this as a diamond pattern, diamond upgrade pattern, and this would be a facet. And then for tokenization, I would use different facets.
I'm not familiar with the diamond upgrade pattern. What that is not.
That's hold on, let me post this.
Let me use this.
Hold on. I got it. You don't have to I'm just putting it in the chat.
Yeah, okay.
Hold on. I'm not that fast. There you go. Yep.
Oh, where's the chat? I'm in full screen. Oh, no, yes, okay, that was what I was looking at.
So you can then decide, you know, you can have different facets. One is sort of like for non-tokenizing, and then others is for tokenizing.
Mm-hmm.
So you have a document that is so since you're, you know, it's like the nice thing about that is it allows you to, because you need an investment contract for a token,
mm-hmm.
or a loan contract, or another document, right, that is based on for example, an invoice or an order or what have you not, right? So on another baseline document, and you include that, right? So you can just check, hey, you're telling me that hash is in that anchor hash, and you can then verify that. You could theoretically verify that also in zero knowledge if you wanted to.
Yeah.
Right. So so that as these general prover frameworks you know, mature, you'll be able, it will just be, you know, it will just be like Solidity, right? And the EVM. So you have multiple contracts, you can do, you know, you can do everything the same way. You'll have upgradable, right, commitments and things like that. Because you can I mean, because the nice thing about with ZK Starks, you can have either, you can say I can do, and it's just a performance question, I don't have to do a trusted setup.
Mm-hmm.
And then it's just the size of the polynomials that I'm using, the number of constraints. I set a max once I do my first once I do the first commitment, and that sort of like sets it. And I can add additional things to those general. So I don't need a trusted setup. If I use hidden number groups as my groups for the elliptic curve. With Plonk, I still do a trusted setup, but I just need to do one, and it's extensible, so I can use that, add one more commitment to that, and then I have a new trusted setup. So that's very flexible, and you can make that very large. You can do like 10 to the 22 commitments, where your typical commitment schemes are like 10 to the 10. So you have a lot of space left.
Oh, wow.
For a lot of programs.
Mm-hmm.
And then or for Starks, you know, you can do the same thing, similar to then you don't need a trusted setup, but your proofs are much larger. So it's like and then it becomes optimizing the size of the proofs. It's really where this is all what it boils down to. If you're doing rollups. zero knowledge rollups.
Yeah.
Because it's like right now, so in the most optimistic case, if I have like 200 bytes for a proof, and I put that into a rollup, then I'm looking at like if I get like 1 megabyte for like 4,500 transactions, and that's kind of like the size of a block right now. And I think the mainnet would be not happy if you just like, oh, I'm just paying you like $5,000 to just anchor that transaction, and or like, oh, okay, and everybody else goes like, wait a second, is that wait, I have like, you just like blew up mainnet because you're paying more than, it's like you're censoring everything because you can only do like what. So you know where that's going, right? So it's the blocker for ZK rollups is the size of the data, even though it's called data, right? But it's still, I don't know what, like 16 gas a byte or something like that. And it's like if you just open up the floodgates, to write like, I don't know, like 2 megabyte call data blocks onto chain, which is like 4,500. It's like, I mean, it's like you're creating like you're creating the largest distributed database in the world, right? You're right. It's like, especially for stuff you don't need.
Yeah.
Right. It's like you really only need this stuff if you want to create an on-chain asset.
Yeah.
Right. Otherwise, it's like don't do it. Don't put it on chain. It doesn't makes no sense.
Yeah, I think then we'll have to kind of rethink a lot of what we've done with Baseline to date.
Yeah, I've told Kai that. Sorry, I'm just gonna blow up everything. Stick a dynamite. Redo.
Well, I think just reinvent until we get it right, or the ground.
Yeah, I mean, it's like, I mean, there's nothing wrong with what it's now, right? It's just, it demonstrates that it works. And if you, think about it this way: if you want like extremely high value transactions,
makes perfect.
That's okay. It makes, if you have a $10 million invoice or or $100 million investment contract, and you do one work step and that's it, and you're paying, you're paying out of your nose, that's fine, right? That's perfectly fine. That's what the current architecture can support, and that's what it's good for. And you do that every once in a blue moon. And that's perfectly fine, right? And you're willing to pay the operator like $10,000 for that one, right? Because it's so much money, right?
Yeah, not to mention the development costs of building the system to do that for you. Because
but I mean, it's like we're talking about like how many $10 million plus transactions do you have worldwide a day?
Probably not that many, and if you do,
not that many, exactly. So it's like how many service provider can that support? Do you know what I mean?
You're right. No, what you're asking about, hypothetically, yes, I don't know, but not many.
So yeah, like what, 2? I mean, just
I don't know,
right. No, I mean, it's like, I mean, if you do 5 transactions of that size a day, maybe 100, right? One can do that.
Yeah.
Right? You do 100 transactions a day. That's like, you can do that right now. That's not a problem, right? So you can do all like 10 million and up transactions done, right? It's like not really, it's not that many. As soon as you go lower, obviously there's significantly more, but in the extremely high value range, there are few.
Yeah.
So it's not sustainable for a healthy provider ecosystem, right? So if you want a healthy provider ecosystem where people can actually, make money, like with DEXs and things like that, then yeah, you need you need scalability that allows you to do, you know, a couple billion transactions a day across, you know, across the entire ecosystem.
Yeah, that's an interesting point you make about just thinking about the ecosystem of providers of this service. I think to date, we've mostly just focused on people who need the service, but not the providers of the service. The quote unquote providers in this scale, this maturity level, are consultants who can build bespoke systems that use this technique.
Yes,
right?
Exactly.
Yeah.
But that's just, I mean, this is just at the very beginning, right? So
Mhm.
this is going to get significantly more sophisticated, because there are, you know, it's like, I'm discussing this within a telco context, and there are like billions of dollars out that are just from settlement alone, that are a pain in the ass to reconcile,
Mhm.
right? And people are using hundreds of millions of dollars every year because they can't get the cash out fast enough.
Can you talk about that just briefly where you can, I guess, because this is being recorded and live streamed, but like understanding that business use case is something I've heard about.
So you
don't
have
know really what's going on there.
So if you're making, let's say if you're in Vietnam and you go to I don't know, the Consensus website,
Mhm.
right? So that's with your smartphone,
Mhm.
right? So what happens? I have a contract with my local ICTSP, so ISP, you know, it's like whatever that is, and wherever that is in Vietnam, right? But they don't have circuits in the US, right? Where it's like based on, it's hosted by, I don't know, GoDaddy or wherever it's self-hosted on Amazon, right? And it's probably the Eastern
circuits,
right?
Did you say you're talking about cellular provider?
Yeah, exactly.
Oh yeah, so they need some kind of NVNM or non-virtual, what is it called, virtual?
That they need to work function virtual. Yeah, they have virtual circuits, right? So they need to create a virtual circuit for you, right? So it's or pack you into existing circuits that they already have running with another provider.
Mhm.
Let's say I don't know, AT&T. Right. So then it hops from the local provider to AT&T to Consensus. So then your local provider and AT&T need to settle because AT&T is not doing that for free.
Mhm.
Right. So they have an MSA between them where they have, you know, where they have orders, right? They have specified, so orders are specific products, and products are based on throughput, latency, you know, what have you not. They're different product parameters, right? Is it dedicated? Is it dedicated circuits? Is it virtual circuits? It's like, you know, MPLS versus, you know, so all the good stuff, right? And then they're packed into an order, and then once the circuits are done being used, because, you know, traffic drops and what have you not, and so then there's billing, right? So that happens. So it says, hey, you used that much, and then so AT&T tells the local provider in Vietnam, hey, you used that much data from this much product, you owe me, I don't know, 50 grand.
Mhm.
And then the Vietnamese provider said, oh no, it's like, I closed that circuit. You know, it's like they're like, I don't know, like 5 circuits, and they have a dispute over when one circuit closed, right? So the entire invoice is held up, right? Because the Vietnamese guy said, no, it's like, I owe you 40 grand, not 50. And then AT&T says, no, you owe me 50. And then they need to reconcile the whole thing. Right.
Yeah.
So now if you were to baseline that, right, you're doing the order, and then you update the order based on when a circuit is closed, either way, right? And then if the Vietnamese guy said, oh, by the way, I'm updating my order now because the circuit closed, it would go to AT&T and say, it's like, oh yes, that's true, or no, that's not true.
Mhm.
Right. So the
you would
order
need to-
status is not updated until both sides agree upon what's the current state of the order.
So you're basically saying the dispute happens closer to real time rather than in a delayed billing cycle.
Exactly.
Yeah.
Exactly. Because now you can't, because now you're connected to through baseline. So there's everything that happens that's relevant to the commercial transaction needs to be communicated. So if we closed these 5 circuits yesterday, and then even if it's delayed and they're like at these times, and then it's like, no, you didn't. It's like, yes, we did. Right. So before you actually build something, right, and once you bill it, you need to accrue for it. Do you know what I mean?
Mm-hmm.
So it has a direct impact on your balance sheet.
Yeah.
So you're loading billions of dollars every month on your balance sheet because of disputes.
Mm-hmm. Mm-hmm.
Plus the cash flow impact.
So the money is locked up in the disputes, and you can't claim it, and you
yes,
can't operate
exactly.
with it, and yeah, you can't leverage it, and all those good things. Yeah.
And it takes like 30 days, 60 days, 90 days, depending on how automated or how manual the stuff is.
So taking it one step further and thinking about like actually implementing it with the baseline system or something like it, does that mean that the hardware, like in terms of specifics, like the actual telco hardware needs to support the ability to talk to mainnet, for example? Like
no.
Like at what level do you baseline, I guess is the question.
Your baseline at the level of the commercial agreement. So if you're closing a circuit, that means you're changing the state of a commercial agreement.
Oh, okay, so the circuit is physical, but then also conceptual in business use case. It's like
right, because the circuit represents a product, right? So you use a product, right?
Okay.
And then you only pay for what you use.
Right. Okay.
Right. And then I've used this product for this much, and I think I owe you this much based on our pricing. And that could be tiered pricing, what have you not. Right.
But at the boundaries where you're crossing those networks, I imagine there's like metering hardware and things that are tracking like what.
It's actually virtual, believe it or not. So it's like the metering is it's like so you have what's called network function virtualization. So you actually have virtual circuits.
Oh. Interesting.
Because otherwise you're ramming everything through a physical pipe. How do you know which one belongs to which?
I don't know. Yeah.
So you're at the entry and at the exit points to the actual pipe.
Right.
Right. You're associating. You have virtualized routers.
Mm-hmm.
Right.
Whatever.
So you don't have a physical. You have a physical router, but right. You actually have virtualized routers.
A layer like a VLAN, like you might do on
exactly. It's a virtualized layer. It's software. It's what you call SDN, a software defined network.
Mm-hmm. Okay, I'm familiar with that from the TCP world, but
right, exactly. It's now you could take that one step further. Now you actually have a VLAN network or have an Ethernet network that's fully virtual.
Okay, so it's at that layer you would need to augment to have.
Yes. So at that layer, you're like, is this virtual network active or not? And then you're like, it went poof on our side, right? Because either on purpose or accidentally.
Mm-hmm.
Right. And if hey, it went down for like 10 minutes, and then we found it, we got it back up, but we only used that much data, not that much, right? Or it was not active at that point in time. So you can. So these are the type of things that happen all the time. They're all a pain in the ass.
Wow.
Right, and you can take that to cars, take that to IoT devices, right? Any digital service has
mm-hmm.
that attached to it.
Mm-hmm.
The settlement of data services, right? It just all magically happens. No, there's like a whole bunch of stuff that's happening in the background. That's why AT&T and Orange and Verizon and China Telecom and so forth are printing money.
Mm-hmm, mm-hmm. Yeah, that's really interesting. I didn't know. I mean, I'm familiar with I guess IoT use case a little bit, but mostly coming at it from consumer and commercial building standpoint. But like, I never thought about metering the services the way telcos do.
Yeah, so they meter it by device, and then they roll this up into product that they're using from another provider based on the routing.
Right. Yeah, and in the case of like an IoT product, you may even have like another layer because like the company that makes the actual physical product and packages it and does the whole user experience.
Yeah, you can you can do that, and you can then, if you want to, you can do the metering, and the device actually controls the billing status. I mean, you can push everything. You can push everything to the edge if you want to, but that is everybody talks about it, but it's like, it's for most people that's a conceptual bridge too far.
Well, it also requires a lot at the edge, right? Which isn't really needed from, I mean, especially a consumer. Maybe for certain, assets in the commercial building.
Oh yeah, I mean, do you know how much Netflix is like? It's like Netflix, Hulu, all the video streaming services are the biggest customers of they're like, if Netflix were to go out of business, AT&T would be hurting.
Yeah, or like maybe hop onto Elon's new satellite delivery of data.
Yeah, but yeah,
like free Netflix and Hulu if you use, was it Starlink or something like that, or
yeah. But I mean, the video streaming comprises like 70% of all network traffic.
Yeah, no, I've seen the stats. It's
right. So it's like yeah. So that's like and and the last mile is actually the issue. The last mile can't handle the traffic, even with a fiber optics.
It just doesn't make sense. Well, yeah, financially, the last mile is a real tough nut.
Yep. Anyway, so that's just a very specific use case that is like literally $1 trillion use case.
Yeah, that's exciting. I mean, I'm always interested to hear use cases for baseline, and a lot of it's been from when we started working on it a year ago is for supply chain, which I'm just an engineer, so I don't really, I just know what people tell me about it, but always curious to find out other ones, different angles.
Yeah, so there's a white paper coming out from the Metro Ethernet Forum, MEF, which is one of the three big telco industry groups. So TM Forum, GSMA, and MEF. And now there's a fourth one that just started, C-band.
Okay.
So, but that's the main thing. Then there are smaller ones like ORAN and so forth. But those are like the big global ones where all the big players are running around.
Cool. All right, good chat with you. I think we're almost at the end of the.
Yeah, so anybody wants to talk about scaling? Continue the scaling discussion. It starts in 5 minutes. Over in breakout room 5. So I gave you the gist already what the result of the discussion was.
You teased it a bit earlier.
A teaser, but you can find everything is documented. It's all in the links and in the instructions document. You can hop in, click on it, and open up the draw.io diagrams and the mind maps there. And so today is focused on sort of like the last thing we're talking about, throughput versus privacy versus security. And then we are going to put that into an evaluation matrix. So the basic one already exists. So the Matter guys have already done that. And then we need to also put requirements together. So someone should then work on that based on what's in the mind map. And then we need to come up with a GitHub story for the hackathon.
Cool.
To build that.
Like an MVP.
To build that out.
Yeah.
Cool. All right. I am hopping off. Great chatting. Talk to you guys later.